introduction to Python. By the end of this session, you should be able to understand what Python is, what is the history behind Python, what is the scope of Python, why prefer Python over other languages, why Python is so popular, and why are people using Python a lot these days despite other programming languages still available in the market, who are the top companies using Python. We'll see how to install Python IDE, and we'll also try running Python program in execution modes. That is the interactive mode and the script mode. I'm excited to get started, and I hope the same from you. Now let's get started with what is Python. So Python is an interpreted, object-oriented, high-level programming language. So let's first understand what the term interpreted means. So basically, programming languages are either compiled or interpreted. Both compiler and interpreter will do the same thing, that is conversion of instructions into machine-level language so that the machine can understand. But here, the mode of execution differs. Interpreted means the conversion of instructions takes place line by line, whereas compilation is nothing but the execution or the conversion is in one shot or in one go. We can also think about interpreter. Let's say we have two people talking to each other. Let's say the first person only knows French, the other person only knows English. So how do you think the both can communicate with each other? Here, obviously, we require a translator that is going to translate French to English and English to French, right? So interpreter basically here is going to act as a translator, which is taking our instructions written in Python programming language and then translating into machine level language so that the machine can understand. Now, what is object-oriented here? We say Python is object-oriented because it supports all the concepts of object-oriented programming, like creation of classes, creation of objects, all the four principles of object-oriented programming, like encapsulation, inheritance, polymorphism, abstraction. In addition to this, we have method overriding, operator overloading, and so on. Now, coming to what is high-level programming language. So here, there are two things we need to understand. One is low-level language and high-level language, right? So low-level language is basically the machine-level language that is in terms of zeros and ones, whereas high-level language is, it's close or similar to English, or you can say, in other words, it is human understandable language. So now we can also say that high-level programming language means whatever instructions we give to the computer to understand or for the machine to understand, we basically write in Python using English as the language, right? We are actually using programming syntax, but actually writing in English language because English is here a universally accepted language, right? So now once the instructions have been given to the computer, once the processing is done, and once it generates the output, is it possible for us to consume that output directly? No, right? Because that output is usually in low-level language or in the form of binary language, that is combination of zeros and ones, right? So now again, it is interpreter who is going to actually convert that into a human understandable language. So this is what high-level programming language means. Now, next, let's move to the next point. So the next point here is it has high-level build data structures with dynamic typing and dynamic binding. Now let's first understand what data structures are, right? So data structures or data types are primarily classified as primitive data structures and non-primitive data structures. Now, what comes under primitive data structures is we have integers, floating point numbers, booleans, strings, and so on. And then in non-primitive data structures, we have arrays, trees, graphs, stacks, queues, and all. So in addition to this, Python is having high-level built-in data structures known as sequences or collections. Now, what comes under the sequences or collections is we have strings, lists, tuple, sets, and dictionaries. Now, with dynamic typing and dynamic binding. So dynamic typing here is, we need not explicitly write the data type of a variable while defining a variable. Let's say, for example, I have a variable A in which I want to store some value like 100, right? So in other programming languages like C, C++, Java, what we do is we say int A equals 100 and semicolon. This is the variable declaration in C, C++, and Java. Whereas in Python, we only write A equals 100. We don't have to explicitly specify that the value 100 is of integer type by writing int. And then we don't have to even end with a semicolon. Because in Python, we get rid of semicolon. There is no semicolon in Python syntax. So that is dynamic typing. Now coming to dynamic binding. So here the memory allocation takes place at runtime. So whenever we have a variable created, we can go and check the address of it using the ID function. And every time we run the code, that will be continuously changing because of memory allocation taking place at runtime. That is known as dynamic binding. So now let's have a look at the history of Python. Let's put some light on the history of Python. So Python was invented by Guido van Rossum in Netherlands. It was invented in December 1989. So this is the person, Guido van Rossum, who invented Python. Now, every time a programming language is invented, a name will be given to it, a name will be coined. Now, how the Python name came into existence is the question here. If we talk about Python in front of some non-technical person, they will think that we are talking about Snake Python, right? So that is not the obvious reason of why Python has been named as Python. The reason is this person, Guido van Rossum, was fond of a famous TV show or British comedy series known as Monty Python's Flying Circus. This person was a big fan of a famous TV show known as Monty Python's Flying Circus. So this programming language Python was named as Python because of this TV show. Now, next point is it is open source from the beginning. So what is open source here? Open source is you don't have to pay. It's freely available. You just need to go to the official website and download and install the latest version from there. So open sources, you don't have to pay, you don't have to buy any license, and even you can go and contribute to the Python community. So Python is open source and freely available since its existence. So this was about history of Python. Now let's move to why are we preferring Python over other languages despite other languages still available in the market, right? We already have C, C++, Java, .NET, and so many other programming languages. But why still Python is now preferred, though it has been invented long back? So let's see. The first and foremost reason is it will take very less time to develop. It means here the development time is going to get reduced, and Python programs are 3 to 5 times shorter programs. So it means here in Python, the number of instructions are getting reduced. So it means the code is going to be smaller. That is why every developer wants to learn Python. You don't have to write long code and all. So let's justify that by looking at this block where we are comparing Python to other languages just to display hello world, right? So if you see this first block here, this block is consisting of Python code where we have print statement, that is output function, parenthesis, inside the quotation we have hello world. So here you can either use single or double quotation. It should not make any difference. So just this single line of code will display hello world in Python. If we try writing the equivalent code in C, C++, and Java, let's see what happens. So in C programming language, you first need to include the header file, standard input-output header files. Then you need to write the main function in main, and then flower bracket, and then printf, that is the output function, hello world, and return 0, and then close the bracket. Same goes with C++. You first need to include the input output stream, and then using namespace standard, and then int main, and inside the curly braces, you need to write your output function, that is cout, and then return 0. Same goes with Java. You first need to have your public class hello world name, and then you need to write your main function, and inside the flower brackets, again system.out.println, that is the output function of Java, right? So if you see here, Python is taking only one single line of code to display hello world, that is print hello world, whereas C++ and Java is almost taking 6 lines of code. So it means that if we have an application or a program written in Java or C++ in 10 pages, the same equivalent program in Python, you can write in just 3 to 4 pages. So that's why Python programs are 3 to 5 times shorter programs. So this is the reason why Python is preferred more over other languages these days, because of the simplicity of syntax, and because here the number of instructions get reduced. Now let's have a look at the scope of Python. So Python has got very, very vast scope, as it is one of the fastest growing language, one of the trending and booming language of today's world. It is one of the best programming language for application development. So let's have a look at applications that are using Python. Let's talk about social media. So we have so many different applications, social media applications that are using Python. We have Facebook, we have WhatsApp, we have Netflix, and we have Dropbox, we have Instagram. So all these applications are using Python in one or the other way. Then Python can be used in web development. So Python has got 2 flavors of web frameworks. One is Flask and the other is Django. Out of this, Django is the trending one because it has got a lot of built-in tools and functionalities. And in addition to these frameworks, we require front-end technologies like HTML, CSS, JavaScript, Bootstrap, React.js to build beautiful websites using Python. Then Python can also be used in game development. So in Python, we have a module or a library known as Pygame, using which we can build a lot of games. Then we can go for system administration, scientific numeric computing using libraries or modules like NumPy, SciPy, Pandas, and all. Python can be used in automation testing, manual testing, geographical information system, mapping, and a lot of things you can do Python. Here we have mentioned only just the basics. There are a lot of things, lots and lot of things you can do using Python. As I already mentioned, Python has got vast scope in different areas of implementation. It can be used in GUI applications as well, using the Kinter module. It can be used in data analysis, visualization, using analysis visualization libraries. It can be used in DevOps engineering. It can be used in machine learning in order to predict the models. And there are a lot of things you can do using Python. Now, who uses Python? Let's go and see who are the top companies using Python. So first comes Google. So what actually Google here is, Google is a search engine. Everybody knows that Google is a search engine. So what we do on Google, we go to Google, we write a query. The query will be taken and forwarded to the Google server, and the processing will be done, and we get back the results in fraction of seconds, right? So Google is extensively using Python in its web searching algorithm. So whatever I have said, like taking the query, forwarding to the Google server, and giving back the results in fraction of second, this complete algorithm is written in Python. Next, we have the hardware companies like Intel, Cisco, HP, Qualcomm. So these companies are using Python for hardware testing. Then we have IBM that is using Python for some of its factory tool applications. And then we have YouTube. So what is the use of YouTube? So YouTube, what people do on YouTube, they go to YouTube. They do searching, but first of all, they create their channels. right? People need to have channels in order to upload their videos or share their videos. So YouTube's video sharing service is written in Python. So Python is used by companies in real revenue generating products. So apart from these companies, we have so many other companies that are using Python. We have Instagram, Facebook, Google, Amazon, Spotify, Uber, Reddit, Netflix, Pinterest. So all of these companies are using Python in one or the other way as a main language or at least supporting language, and they are generating real revenue. That is, they're earning a lot of amount using Python programming language. So let's see, how do we install Python IDE? So Python is pre-installed on most of the Unix, Linux, and Mac operating system. Python comes in two versions. One is 2x, the other is 3x. So 2x is almost depreciated, and 3x is the one which is latest. But on these systems, Unix, Linux, Mac, we have Python 2x. We need to write a command to upgrade it to 3x. But if you are a Windows operating system user, you can download Python from this link. That is https www.python.org. Go to downloads page and you can download the Python interpreter. You can go to the, you can download the latest version of it. It's 3.11 point something as of now. Now let's first understand how the internal execution of Python takes place. So we do have a source file here, that is m.py. Okay. So .py extension here means whatever code we have inside our file, that is a Python file, right? So what's happening next? It is getting converted into bytecode, that is .pyc code. If you see here, m.py has been converted into a bytecode, that is m.pyc, and that is later interpreted by PVM, that is Python virtual machine, at runtime. So what's actually happening here? The source code is getting converted into bytecode, which is later interpreted by Python virtual machine at runtime. So now, looking at this execution, we may say that Python is compiled, right? Because we have a .pyc file generation over here. So now the question arises, is Python interpreted or is Python compiled? So the answer to this is Python is actually both compiled and interpreted to the system end, but it is only interpreted to the user end. So that is why we don't have to go into the internal implementation. We as users only say that Python is interpreted. So we will be using PyCharm IDE for Python. So in order to work with PyCharm IDE, you just need to go to this particular website, that is www.jetbrains.com. So PyCharm is the product of JetBrains that comes in two editions. One is professional edition, the other is community. So professional is paid. You can just go with the community edition and download and install the latest version from here. So once it is done, you can either configure the path, or if you have installed your Python interpreter properly by setting up the environment while installing, then you don't have to actually explicitly write the environment paths. Now let's see how to run Python program. So Python has two different execution modes. One is the interactive mode and the script mode. Now let's first run our Python program to display hello world. So now what I'll do is, once we have installed Python from python.org, what we can do is, once we have downloaded, once we have installed, we can just go to our search menu or start menu. So let me just open. So I'll go to my search menu and start typing Python. So you see I have Python 3.11 64-bit. So I'm going to open this. So this black screen here is a Python interpreter. If you see here, we have three angular brackets or three chevron symbols. And here it's written Python 3.11. So you should not get confused with this as maybe this is a command prompt, right? So this is not a command prompt or a terminal. This is the Python interpreter. So these chevron symbols are indicating that we are inside the Python interpreter. So now what I'll do is here I'll write down uh, something like 2 plus 2. I want to add 2 plus 2. So once I write 2 plus 2 and hit enter, you see the output I get is 4, right? So the other thing I would like to try subtraction. So let me say 5 minus 2, and there we go. I get the output as 3. I can try with multiplication as well. Let's say 4 into 6. So here asterisk symbol is used for multiplication. So that should give me the output as 24, right? So now what if I want to print something? Let's say, for example, I want to print hello world. So what have I done? Print function, parenthesis, inside the quotation. I'm using single quotation here if you see, and then closing. So this should give me the output as hello world. Same thing I can do using double quotations as well. So because hello world is a string, we need to enclose that in either single or double quotation. So now you see I get the output as hello world. Let me try printing something else. Let's say hi and hit enter. You see I get the output as hi, right? So whenever we are directly working on the interpreter mode or the Python shell directly, that is known as interactive mode, right? So now there are two drawbacks of using interactive mode. Let me explain you both of them. The first drawback is that, see, whenever I'm writing something, let's say I would like to do 3 plus 4, okay? Once I hit enter, you see I get the instant or immediate output of it. So it means that it is not allowing me to write more than one line of code. It is just executing the single line of instruction and giving me the instant or immediate output of it, right? So this is one drawback where I cannot write a block of code. That is, multiple lines of code cannot be written. That is one drawback. Another is, let's say here in print hi, I was actually supposed to write hello, and by mistake I had written hi. So is it possible for me to go and change this hi to hello? It's not possible, right? Because this is already executed and it remains in the active part of the memory. So what I can do is I can just go and change that particular instruction. So this is my new instruction. I'm not able to modify the code in other words. So now I can say print hello and I get the output as hello. So these are the two drawbacks. The first one is you cannot write multiple lines of code or block of code. And the other drawback is you cannot modify your code. So these are the two drawbacks of interactive code, which is leading us to the interactive mode, which is leading us to the script mode. Now, how will you write the script mode? So what I'll do is I'll simply go and open the simple notepad. And here, let me write a couple of instructions. Okay, so here I'll say print hi. And here I'll say something like print welcome to HKR trainings. And next line I would like to say is Python is easy. And now let's say, let's learn Python. At HKR trainings. All right. So now what I have to do is I actually have to go and save this file somewhere. So what I'll do is I'll go to this file, do save as, and I want to save this on my desktop. So here I need to go and give the name of the file. Let's say file1.py. So the extension here is really important. Otherwise your code would be, or your file would be text document by default. So I'm going to save that and let me minimize this. Now what I will do is I will open my terminal, that is command prompt. Okay. So now you see this is my command prompt. This is not Python shell, if you notice. This is my command prompt. Now I need to check if Python is present in my system or no. So there are two ways of doing. One is you can go and write Python -- version and hit enter. You see it says I have Python 3.11.3 installed, right? Another way is you can just go and write Python. You don't have to write -- version. But once you write Python and hit enter, it should take you to the Python shell. So there we go. You see these angular brackets or chevron symbols are indicating that we are inside Python shell. So now again, I'll try doing something like 2 + 4. That gives me output 6. Let me try multiple subtraction as well. Multiplication, there we go. Now let me say print high, enter. You see, I get the output as high, isn't it? Now I want to go back to my C drive or C directory. What I'll do, I'll say exit. And now I'm back to my C directory. Now, what am I supposed to do? I need to go to the location where I have saved my file. So that is desktop. So I'll do here cd desktop, enter. So I am inside my desktop where I have saved my file. So now how can I execute that? I need to write Python followed by name of the file. So the name of file is file1.py and hit enter. There we go. You see the output is the same instructions that I have written on my notepad. So it's hi, welcome to HKR trainings. Python is easy, and then let's learn Python, isn't it? So this is how you can execute your block of code. This is also known as script mode, wherein you're writing your code somewhere and you're running from somewhere, right? For this, you can also make use of IDEs like PyCharm or Visual Studio Code or any IDE you prefer and you're comfortable with, right? So now what I'll do is I'll try modifying this code. Instead of hi, I'll write hello here. Once I have done, you see there is a star symbol here. It means it is not saved. So what I'll do Control S. Now it has been saved. Again, I'll go back to my C drive, and here I'll write down the command Python followed by name of the file and hit enter. So now you see it says hello, welcome to HKR training. So you see hi has now been modified to hello and rest of the statements remain same. So this is how you can make use of the script mode. Now we will try to run the code on PyCharm IDE. So I'll just go and open my PyCharm. So if you see, I already have created a project by name HKR_trainings. So this is the main.py script. That is the default script that you get. You even have an option to uncheck this main script. So what I'll do here is I'll right click on the project name, go to new. And you see in Python, we have so many different options. We have an option to create a file, a scratch file, a directory or a folder, Python package, Python file, and we can also create HTML files. So I'm gonna go to this Python file and name this to be something like demo. So here, whenever you're creating a file in PyCharm, you don't have to give the .py extension because the type of file is already Python. So you just give the name of the file, hit enter. You see, automatically it's creating demo.py for us. You don't have to give the extension .py. So now what I will do is, so here also, let me first go and write hi. And this is the area where we will be writing our instructions or our code. This is basically our workspace. And let's say something like Python is fun to learn, right? So now once we have these two instructions, I can go and run this. So how do I run? Because I'm running this file demo.py for the very first time, I just need to go to this run button here. Click on this second run, not the first one. This is already a file which has been selected. It's going to run that file, not your current file. So if I click on this run and I need to click on the demo, and there we go. You see, this is the output console that pops up whenever we go and run the code. So this is the output console where we can see the output as hi, Python is fun to learn. If you want to rerun this code, you can simply click on this green button. You can see it reruns, or you can click here, provided the current file is already selected over here. So let me make some changes, like let me write something else. Let's say hello world. And now when I go and rerun, you see, I get the output as hello world as well. So here you don't have to save your file. The changes are automatically loaded. You don't have to do every time Control S whenever you're writing some specific instructions. Now coming to what dynamic binding is. So I already explained you what dynamic binding is. Let's try doing that here. So for example, if I want to store a value 100 in some variable like a, so a equals 100. Before that, if I write a equals 100 semicolon and then print a. Let's go and see what happens. So I'm simply gonna run from here, and you see it gives me an error saying invalid syntax. So this is not how we declare or define a variable in Python or assign a value to a variable. So we don't have to explicitly write this. So this goes off. And also the Python syntax doesn't support semicolons here. So I need to remove this. So now I'm going to quickly run. And now you see the output is 100. So this is dynamic typing where you don't have to explicitly write the data type of a variable, but you can know the type of variable at runtime. So how do we do that? Print using type function. So when I say type A and run, you see the output is class int, meaning 100 is of integer data type. Hello everyone, welcome to HKR trainings. In this session, we'll be learning about Python variables and data types. By the end of this session, you should be able to understand variables in Python, variable declaration, what are variable assignments, data types in Python, number in Python, strings in Python, and type conversion. I'm excited to get started and I hope the same from you. Now let's get started with what variables in Python are. So variables in Python are nothing but containers or box for storing or holding the values. Let's say here I have a variable a in which I want to store some value like 100. So I need to just write a equals 100, where a is the variable and 100 is the value that I'm trying to store in this particular variable. Variables are also entities of a program that hold the value. You can imagine variable as a cube kind of box inside the memory that stores the value, and the name given to the box is your variable name. So here, if you see, there is a cube kind of box that is holding value 100, and the name given to this box is a, that is the name of variable. So I hope the concept of variables is clear. Now let's go and see how we can have variable declaration. So Python actually has no command for declaring a variable. Now, why do we say that in Python we do not have a command to declare variable? It is because in Python, a variable is created the moment we first assign value to it. It means as soon as I write a equals 100, at that particular moment, a variable a is created that is holding the value 100. So we don't have to explicitly write the data type of a variable. We don't have to say int a equals 100 followed by semicolon. So that is why here we say there is no declaration of a variable. Instead, we say variable is assigned, or the variable is created the moment we first assign value to it. And in Python, variables can be redeclared or reassigned. For example, initially, if I say a equals 100, and after some time, I change the value of a to 200, and later on, whenever I refer to a, it will be holding the very latest value, that is 200, and the value 100 will be overridden because that becomes the old value. So in this way, variables are redeclared or reassigned in Python. Now let's see how we can have variable assignments. So any values can be assigned to variables. It can be of any data type. It can be integer values. It can be floating point values. It can be booleans. It can be strings and so on. And it can even be negative numbers as well, negative integers, negative floating point numbers, and so on. There are two types of variable assignments in Python. The first one is multiple variable single assignment, and the second one is multiple variable multiple assignment. So in multiple variable single assignment, as the name suggests, we will have multiple variables and all of them will be holding single value. That is why it is known as multiple variable single assignment. Now coming to multiple variable multiple assignment. So here, as the name suggests, we will have multiple variables. All of them will be holding two different values. That is why it is multiple assignment. So we will be looking at the syntax of how to define multiple variable single assignment and multiple variable multiple assignment once we hop to the PyCharm. So let's see what are data types in Python. So Python has wide range of data types. It has got integers, that is basically numbers. It has got integers, floating point numbers, complex, booleans, and it has got sequences or collections like strings, tuples, lists, sets, and dictionary. So in case of integer, floating point, and boolean, what we do is we have a variable and we simply assign one single value to it. But when we work on real-time applications, we need to hold on to multiple data that could come from any database source, any RESTful service. That will be a continuous data, right? So for that reason, we need to have sequences or collections. So now coming to the 5 kinds of data types, we have none type, we have numeric types, including integers, floating point numbers, and complex numbers. Then we have sequences, including strings, lists, and tuples. Then we have sets and dictionary, also known as collections or sequences. So set here is an unordered and unindexed sequence or collection, whereas dictionary is a map of key value pair, hash map of key value pair. Now let's see what number in Python is. So there are 3 numeric types in Python. First one is integer. So integers are nothing but whole numbers that will not have decimal point in them. Floating point value is the number which is not a whole number, which will have a decimal. For example, if I say 10, 10 is integer number. And when I say 10.0, that becomes my floating point number. It need not be only 10.0. I can have anything after point. Let's say 10.2, 10.5, and so on. Now, what about complex numbers? So complex numbers will have two things. It will have a real part and an imaginary part. So for example, if I say 2 plus 3j, 2 becomes my real part and 3j becomes my imaginary part, where j is the standard coefficient. Now, variables of numeric types are created when we assign value to them, and it is possible to store negative values inside the variables. Now let's see what are strings in Python. So let's say we have to store some letters in variable. Let's say I have to store Python or I have to store HKR trainings. So we'll first discuss what strings are. So strings are nothing but sequence of characters that are enclosed in either single or double quotations. So if you see this example, name and name. So name is a sequence of letters, and this name is also a sequence of letters, but the first one is enclosed in single quotation and the second one is enclosed in double quotation. So the quotations are not going to make any difference here. That's why this name and name both are same. Now, what actually is string? Anything we write inside the quotation would become a string. It need not be only characters. It could be numbers or digits as well. So when we write numbers or digits in quotation, they are no longer known as numbers. Instead, they are interpreted as strings. Now we can display string using print function. So we just need to have print function parenthesis And inside quotation, either single or double quotation, we can mention our string. It can be a sequence of characters, or it can be sequence of digits or numbers, or combination of sequence of digits and characters. So for example, let's say string 1 here is HKR trainings. If you see this HKR trainings is enclosed in double quotation. So if I have to print this, I need to write print statement inside the quotation in either single or double quotation. I just need to write HKR trainings. Also, we can assign string to a variable. If you see here, I have assigned this string to a variable, and the name of variable is string1. So let's see what type conversion means. So type conversion here is nothing but typecasting that is used to convert one data type into another. Let's say, for example, we have to convert a floating point number to integer. So here we will have floating point number as the source, and we are going to convert that into an integer number that becomes your target. We can also convert integer number to floating point number. We can convert to string to a number, either a floating point number or an integer number. So we will be applying this type conversion to most of the data types. Now let's hop to PyCharm and check out the examples of variables and data types. Now, before hopping to PyCharm and checking out the example of variables and data type, we will first have an example of variables created on the Python shell or Python interpreter. So this is the interactive mode. Here, what I'm going to do is, let me take a variable to be x equals 2. And if I hit enter, yeah. Let me take another variable. Let's say y equals 3. And now what I'll do is I'll say something like x plus 4. So now what should be the value of this x plus 4? We already have value 2 stored in x, right? So x will become your 2 plus 4 is we are adding 4 to 2. So that should be 6. Similarly, if I do x plus y, I should get the output 5 because 2 is stored in x and 3 is stored in y. If I want to individually check what is the value present in x and what is the value present in y, I can say x, hit enter. I can say y and hit enter. So whenever we are directly working on the interpreter, we don't have to write print statement. But when you're working on the IDEs like PyCharm or Visual Studio Code, you cannot directly check your variables like this. You need to say print x, print y, and so on. Here also, I can go into print x, but I also have an option to skip print and directly check the value of variable. All right, so now what I'll do is I'll say x equals 7 and then x plus y. So now what's happening? The initial value of x is 2. Now I have changed the value of x to 7. So whenever I refer x, it is not going to be referred as 2. Instead, it will be referred as 7 because 7 is the latest value. So the value 2 is now overridden by the new or latest value 7 that is stored in x. So now if I hit enter, x is 7, y is 3. So the output is 10. So this is known as variable declaration or variable reassignment or redeclaration, right? So now if I do something like x plus 10 and hit enter, you see I get the output as 17. And also there is something called underscore. So underscore will be holding the very previous immediate output. So here the previous immediate output is 17. So if I hit enter, you see underscore will be holding the previous output. So if I say underscore plus 3, underscore is 17 plus 3 would become 20. So this is how we can have variable assignment and redeclaration or reassignment. Now let's go to PyCharm. So here, what I'm going to do is I'm going to create a file. I'm going to right click on the project name, go to new, create a new Python file and name this to be variables. Hit enter. So you see, I haven't given the .py extension because the type of file was already Python file. So the .py extension is automatically taken over here. So here, what I will do is I'll write a comment saying variables are containers or box for storing values. For example, if I say a equals 10 and print the value of a. So 10 is the value that is stored in a variable called a. So let me run this. Because this variables.py file have not been run yet, this is the first time we are running. So I'll go to my run here. I'll click on the second run, or you can do Alt Shift F10 as well. So go and select the file, and there we go. This is the output console, wherein we can see the output 10. I can also store some string value in my variable a. Let's say I want to store some value like John. And if I print a, what should happen if I go and run? Now the value of a will be John and not a. The value, not 10. The value 10 has been overridden by the value John. So now coming to numeric types. If I say a equals 100, print a. So 100 is the integer number that I'm storing in a variable called a. So this is an int. Let me run. You see the value is 100. All right. Similarly, if I say b equals 100.0 and print the value of b, so 100.0 here is the floating point value. So here I'll say it's a float. Now when I go and run, you see the output is 100.0. So because it is having a decimal point and it's not a whole number, that's why it's known as float. Now let's talk about complex numbers. So when I say c equals 2 plus 3j, so as I already mentioned, complex numbers will have two parts. One is real part, that is 2 is the real part here, and 3j is the imaginary part where j is the standard coefficient. So now when I go and do print c and run, you see the output is 2 plus 3j, isn't it? Now what I will do is, we will look at the case sensitivity of variables. All right. Now, when I say name equals something like Sam, name equals Sam, and name equals Sam. And print. So if you see the first name here is written in all small letters, that is lowercase. The other one is title case, and the other one is uppercase. So if you look at the spelling, name, and name, all are same, storing the same values, but all of them are different variables because variables are case sensitive. So now if I go and run, you should see Sam, and Sam as the output. Now let's say I have to create a variable. Let's say a equals 10, b equals a, and I need to print the value of a, I need to print the value of b. All right. So a and b both will be 10 and 10. B is a because a is already 10, b is indirectly 10 here. Now, I want to find the memory address. So here what I'll do, I'll say this is more on variables. So I'm trying to find the memory address of a variable using the ID function. So I'm going to write ID of A. So this will return memory address of a variable. All right, so let me run and check. You see, we get some big number ending in 7304. So this is the memory address of variable A. If I try rerunning it, and if I go and have ID of B and run, you see, the ID of both A and B is actually same, that is ending in 7304. Now, why the ID is same? Because A and B are both holding the same value 10. If I also have one more variable C equals 10, and if I say print C, also find the ID of C. So now the question is, will the ID of C be same as that of A and B? So let's run and check. There we go. The ID of C is still same. The reason is inside the memory, there is a box created holding value 10, and all the variables that are storing value 10 will be pointing to this particular box. Hence, the memory address of that particular box remains same. Now, what happens if I go and do A equals 11 and then print A and also check the ID of A and run? There we go. Now you see the ID has been changed because A is no longer pointing to a box that is holding value 10. Instead, inside the memory, there is a new box created holding value 11, and A is now pointing to that box. Hence, the address changes. So this is how Python does automatic memory management. Now coming to variable assignment. So the first one we have is multiple variables single assignment So let me say A equals B equals C equals some value like 5. So here we have multiple variables and all of them will be holding the same value. That's why I've assigned A, B, C, all of them to 5. Now here I can say A, comma B, comma C. And now when I go and run, you see the output should be 5, 5, and 5. This is multiple variables and single assignment. Let's go and see the other type, multiple variables and multiple assignment. So here I'll say multiple variables, comma multiple assignment. So for multiple variables and multiple assignment, we will have different variables, let's say X, and we will assign multiple values. Let's say X is 10, Y is 20, and Z is 30. Now I want to print X, comma Y, comma Z. So if you notice below 10 and 20, we have some red squiggly line that actually indicates an error. So let me run and check. So here you see this is syntax error, invalid syntax. The reason why we are getting error is that whenever you have multiple variables and you want to assign multiple values, you can have X equals 10 on one single line and Y equals 20 on the next line and Z equals 30 on the next line. So now if I run, you see I get the output 10, 20, 30. So here actually what am I doing? I'm declaring the variables on different lines. Instead, when I have to do on the same line, all the variables should be on left hand side, and all the values should be on right hand side, separated by commas. So let's say x comma y comma z equals 10 comma 20 comma 30. So you see here the variables are on left hand side and the values are on right hand side. So variables will be taking the respective values. X will take value 10, y will take 20, and z will take 30. So now when I run, you see I get the same output 10, 20, and 30. All right. So next, if I have 40, 40 here. Now let's check what will be the output. So you see, I got an error, that is value error, that says too many values to unpack. So it is just expecting 3 and we got the value 4. 4 values, right? Why? Because here the number of variables and number of values are not same. So we need to make sure that the number of variables are equal to number of values. So in order to do that, after z, I'll put a comma and write u. Now let's run and check what will be the output. All right. So now if I run, I get the output 10, 20, 30, again the same output. The reason why am I not getting 40 is because I'm not printing the value of u, right? So printing it depends. Out of all of them, I can just print x or print y or print z or print all of them. It should not make any difference, but the number of variables should be equal to the number of values. So now you see, because I have added u inside the print statement, 40 has been printed. So this is about variable assignments. Now what we will do is we will go to the project name, create a new Python file and name this to be data underscore types and hit enter. So here I'll be saying that Python has wide range of data types. So the very first one that we will see is none type. All right. So let's say I have a variable a and I do not have any value to store inside it, but I want to print that a. Okay. So now let's run and check the output. So I'll click on run, click on second run and click on data types. Now you see, I got the error, syntax error, invalid syntax. Obviously, there is a variable created, but we are not storing any value in it, right? So whenever we do not have any value to store in a variable, we can just go and write this none keyword. And now if I run, you see the output is none. Also, we can find what type of data is stored in a variable using the type function. So I can say print inside the print type of a. All right. So now when I go and run, you see it says it's class none type. Now similarly, if I talk about the numeric types, if I say a equals 10, print a and also check the type of a. So here a is the variable and type is a function that is going to check the data type of the value stored inside a. So now when I run, you see the output is 10 class int. Similarly, I'll check if I can have any negative value. Let's say a equals minus 15, print a, and then type of a. And now when I go and run, you see the value stored in a is minus 15 and it is of integer type. That's why it gives class int. Likewise, if I say f equals 10.0, print f and print type of f. So now if I go and run, you see this is 10.0 is the value of f and it belongs to class float. So that is floating point number. You can even have a negative floating point number. So I'll just put a negative sign over here. And now when I run, you see the output is class float, minus 10.0 and class float. Similarly, if I say C equals something like 3 plus 4j. So we have already seen that these kind of data types can be stored in variables. We will just check the type here once we print the variable. So print C, print type of C. So now if I run, you see this is class complex. So 3 here is the real part and 4j is the imaginary part and j is the standard coefficient. So when I say j is the standard coefficient, let me check if is it possible to have any other character except for j or other than j. For example, if I write 3 plus 4i. So you see there is a small squiggy red line below I. And now if I go and run, you see it gives me an error saying invalid decimal literal. So whenever you have to write a complex number, you should always have j as the standard coefficient. So now you see I get the output. I can also reverse this. I mean, I can first go and write something like 2j plus 3 and I can say print C, also check the type of C. And now when I go and run, there we go, you see it automatically considers 3 as the real part and 2j as the imaginary part and gives the same output 3 plus 2j. And the type of it is class complex. Now let's talk about strings. So let me first display some string using the print function. So here if I say print HKR trainings, and run, you see I got the output as HKR trainings. And if I want to specify this string using a variable, or if I want to store the string or assign the string to a variable, I can say something like s equals. I can write this HKR trainings in either single or double quotations. And then I can go and print the value of variable s. Also, now I can go and check the type of it by writing print type of variable s. And now when I run, you see the output is class str. So str here is nothing but string. Now next, let's go and see what a Boolean is. So Boolean basically results in either true or false. For example, I'll take a variable, let's say g equals, I'll assign the value true to it and say print g and also check the type of g. Okay, so now if I go and run, you see the output is true and it's class bool. You need to make sure that the T of true should be caps. If I write this small, you see I get an error because true that starts with capital T here is a built-in. So that's why you can make use of built-in value and assign it inside a variable. So now what I can do is I can put this inside quotation. So this true will no longer be true that is belonging to bool class. Instead, it will become my string, right? So that's why true here is a built-in and I'm assigning that to a variable. Similarly, if you assign a value first, then f has to be caps. Another thing what I can do here is I can just make comparison of numbers and that should give me the output in the form of true or false. If I say 3 is greater than 2, so if this condition is true, then it should result in true. There we go. This is true. I can also go and check the data type of it. So how do I do that? If I say something like h equals and print h, let me run and check. So it says none. So what I can do here is I can say not variable. I can directly say type of 3 greater than 2. So what it will do, it will just tell me if the class is bool. There we go. You see the output it says is class bool. Or I can say a equals 3 is greater than 2. I can print the value of a, also check the type of a. So again, now if I run, you see the output is true and class bool. So this is how we can make use of booleans. Now we will see how to represent a number in different formats. So I'm going to represent my integer number in different formats. For example, let's say I have to represent number A in 3 different formats. Let's say I have to represent in binary, hexadecimal, and octal. So in order to represent our integer number 10 in binary, hexadecimal, and octal, we have built-in functions. So we'll try using that. So I'll directly write print statement. And for binary, I can make use of bin. If you see here, it shows it's a built-in. All right. And now I can specify the number that I want to represent in binary. Similarly, I can say hex of 10 and oct of 10. And now when I go and run, you see we get the output 0B1010. So here 0B stands for binary and 1010 is the binary representation of integer number 10. Similarly, 0x stands for hex and A is the hexadecimal representation of integer number 10 and 0O stands for oct and 12 is the octal representation of integer number 10. So here I'll change the value to 12 and 12. So for 10 it is A and 12. For 11 it will become B and 13 and for 12 it should become C and 14. Let's go and check. There we go. For hex of 12 it is 0xc. For oct of 12 it is 0O14. So this is how you can represent integer number in different formats. Now let's see how we can do type conversion. So type conversion is nothing but typecasting. So that is converting one data type into another data type. So now what I will do is, let's say I have to convert integer number to float. So because we have to convert integer number to float here, we first need to have an integer number stored in a variable, right? So what I'll do, I'll say a equals 10. I'm going to print and check the type of it. Though you can directly do the conversion and then check, but I first want to confirm that a is the variable that is holding my integer number. So it should say 10 and class int. Now I have to convert this 10 into float. Okay. So again, after conversion, I need to store in some variable. Let's say that variable is b. B equals float because the target here is float of a. You need not write 10 here. You should write the variable a. And then print b. Also check the type of b. So now when I run, you see the output is 10.0 and class float. Similarly, if I do the reverse, let's say I have to convert a float to int, that is floating point number to integer. So I'll take x equals, first initial value I need to have is of floating point number. So I'll say something like 10.2 print x, also check the type of x, and let's say y is a variable that is going to hold the converted result. So the target here is int. I need to first write int and then pass x to it. Now I can go and print y and also check the type of y. And now if I go and run, there we go. 10.2 has been converted to 10 and class float has been changed to int. This is how we can convert one data type into another. Now let's try converting a string to number. Let's say integer number. All right. So what I'll do is I first need to have a string, isn't it? So I'll say a equals, I'll make use of the string Python. I want to convert this into an integer number. So I'll say print a, also check the type of a. Then I'll say b equals int of a, also check, sorry, print b and also check type of b. So now let's go and see what happens. All right. So let me quickly run and see. There we go. You see the output here is value error, invalid literal for int with base 10 Python. So why are we getting this error? The reason is whenever we have to do the type conversion, we cannot make use of this character string. Instead, we need to have a number string or numerical string. So what if I put something like 100 here? Okay. So this 100 here is no longer a number. This becomes my numerical string. So for conversion, you have to make use of numerical string. So now if I go and run, you see the output is 100 was class string and now 100 has been changed to class int. This is how you can convert a string to either integer number or floating point number. Now let's try if we can convert an into complex. So for that, I first need to have an integer number. Let's say it is x equals 10, print x and print the type of x. Let's run and check. So this is my int. I have to convert this into complex. So what I'll do, I'll say y equals complex of x, print y and also check the type of y. Now let me run and check. Now you see the output is 10 plus 0j, because whatever integer value we give, it will be considered as the real part. And because we do not have any imaginary part, so it will automatically take 0j. 0 is the imaginary, 0j is the imaginary part, where j is the coefficient. Now let me try doing the reverse. Let me check if I can convert a complex number to integer. So here I'll say a equals, I will have 2 plus 4j as my complex number and print a, also check the type of a, and then b equals, here if I say int of a, print b, and then print the type of b. So let's run and check. So there we go. You see here, it gives me an error saying b is equal to int a will not work. because int argument must be string, a bytes like object or real number or not complex. So it means that we cannot convert a complex number into integer. Instead, we can convert a integer number into complex number. Now, let's have some discussion on mutable and immutable objects. So I'm gonna say mutable and immutable objects. So everything in Python is made up of object, right? So object here is a generalized term, but whereas in other programming languages, object might be a data structure or something else, but in Python, it's a generalized term. So now we will see what mutable and immutable objects means. So let's first talk about mutable objects. So mutable objects is the sequence types that can be changed, or we can, in other words, says it can be modified at any point. So example for these mutable objects are, we have lists, we have sets, we have dictionary. So these are the sequence types that can be changed at any point. You can add elements to them, you can remove elements to them, or you can copy them, and so on. Now talking about immutable objects. So immutable objects here are the sequence types that cannot be changed or cannot be modified. Cannot be changed or modified. These are unchangeable or unmodifiable. Once defined, you cannot change them. Here we have int, float, that is the basic data types. Then coming to sequence, we have strings, we have tuples, and also we have Boolean. So once defined, you cannot change these basic data types or sequence types. So this is known as, these are known as immutable objects in Python. By the end of this session, you should be able to understand what are operators, and we will be looking at the different types of operators available in Python. Let's get started. Now let's see what are operators. So operators are used to perform operations on variables and values, and Python divides operators into following groups. We have arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. Now let's have a look at the Python operators. So here we have the operator and notation. This table represents the operators and their notations. So in arithmetic operators, we have addition, subtraction, multiplication, division, floor division, power, and modulus. In assignment operator, we have equals. Comparison operators, we have double equals, that is going to check the equality. Then not equals, greater than, lesser than, greater than or equal to, lesser than or equal to. In logical operators, we have and, or not. In identity operators, we have is not. Membership operators are in and not in. And bitwise operators are bitwise and, bitwise or, XOR, and negation. Now let's hop to the Python and check out the example of Python operators. Now here I'm on the Python. I'm going to right click on the project name, create a new directory here, and name this to be operators. All the operators related file will be creating inside this directory. So now here inside the operators, I'm going to create a new Python file. And let's first go and see what arithmetic operators are. Let me name this file to be arithmetic operators. Hit enter. So let me list down the arithmetic operators here. So we have plus, minus, asterisk for multiplication, division, floor division or integer division, and then we have power and modulus. Now let's have a look at the example. For example, if I say a comma b equals 10 comma 5. So here I'm defining two variables, a and b, where a is 10 and b is 5. Let me write a print statement that says addition is, sorry, this should be addition is colon comma, here I can say a plus b. Now whatever I'm writing inside the quotation would be printed to the output console, and this is the computational formula for addition. And then I can do for subtraction as well. Subtraction is colon a minus b. Can say multiplication is colon a into b. Print division is colon a divided by b. And print, let's talk about floor or integer division. Floor div is a double slash b. I'll explain you what is the difference between division and floor division in a while. And then print power is colon a double star b, and print modulus is colon a mod b. So now let's run and check the output. So I'll go to this run button, click on second run and select the file that I want to run. Let's say, there we go. Now you see the output is addition is 15, subtraction is 5, multiplication is 50. That is 10 plus 5, 10 minus 5, 10 into 5. Division is 2.0 and floor division is 2. So the difference between division and floor division is that division will give you the value in the form of a fraction, or there will be a decimal point in it. Floor division will only give you the integer part. That is, it is going to truncate or eliminate the point or a decimal point from the value. And power is 10 to the power of 5 and modulus is 10 mod 5. That will give you the remainder value. Remember, modulus is not the quotient, it is the remainder value. Now let's move to the next type of operators. Let's say this is assignment operators. Hit enter. Now what exactly are assignment operators? So assignment operators are used to assign values to variables, or it can also be used to assign expressions on right hand side to variables on left hand side. Let me list out assignment operator. So this is equals. Now let's say I have a variable a equals 10, b equals 2, and here I'll say print a comma b. So now when I go and run this, I get the output a as 10 and b as 2. So comma here is going to add the space between 10 and 2. Now there is also something called compound arithmetic operators. Now let's see what this compound arithmetic operators will do. So here we have plus equals. For example, if I say a plus equals b and print the value of a, this is as good as doing a equals a plus b. So whatever computation we are doing, we are storing back the result in the same variable a. So now what should be the output? A is 10, b is 2, and it should be 10 plus 2, 12. So I'm going to quickly rerun. And now you see the output is 12. Similarly, a minus equals b. And now when I say print a, this is a equals a minus b. So now what should be the output of this? The output here is not 8. The output here should be 10. The reason why it should be 10 is the recent value of a is 12 and the value of b is 2. So when you do 12 minus 2, it becomes 10. So you do not take the original value of a 10 and then subtract 2 from it. Because here every time we are getting the output, we are saving the result back in a. Similarly, a asterisk b, print a, this is as good as doing a into a asterisk b. And then a slash b, a slash equals b, print a. Another important thing here is that whenever you have two operators together, there should be no space between the operators. If I try having a space here, this will give me an error. Though you can have space between the variable and the operator, same here as well, but there should be no space between the two operators that we are writing. So this is doing a equals a by b. Likewise, here we will have a power equals b. That is as good as doing a equals a to the power of b and then print a. So let me run now. 10 into 2 is 20. You see the output is 10 to the power of 2 is 100. And then let's go and see the last one, that is modulus. So here I'll say a modulus equals b and then print a. So the recent value of a is 100. A equals a mod b. And now when I run, you see the output is 0. So this is what assignment operators do. Now let's move to comparison operators. I'm going to create a new file and name this to be comparison operators. Now comparison operators also known as relational operators what they do is they compare values or let me say compare two values and results in either true or false. So now let's go and check out the example for this. I'm also going to list out the comparison operators. The comparison operators are double equals, sorry. And then we have not equals, greater than, less than, greater, greater than or equal to, and less than or equal to. So let's say we have two variables, x comma y equals 50 comma 60. Now I'm going to check if the value of x equals y. So here if you see the value of x is 50 and the value of y is 60. So I'm going to check if 50 is equal to 60. So this should give me false because here the value of x and y are not same. You see the output we get is false. Similarly, if I say if x is not equals y, and now when I run, it should be true because 50 is not equal to 60. Likewise, if I check for x greater than y, so x is 50, y is 60. 50 greater than 60 is false. So we get the output false here. If I go and check for x less than y, this is true because 50 is less than 60. And then x greater than or equal to y. So wherever you have this do x greater than or equal to y or less than or equal to y, either of the conditions should satisfy here. So when I say x greater than or equal to y, x is not equal to y, we know that. And also x is greater than y is also false. So it should give me false. Right? Now the last one we have is x is less than y, less than or equal to y. So here x equals y is false, but x less than y is true. That's why you get the output as true. So this was about comparison operators. Now let's go and see what logical operators are. So I'm going to create a new file, name this to be logical operators, hit enter. Now what are logical operators? So logical operators are used to combine conditional statements. So it means we are going to make use of the same conditional operators that we have used, and on that we will be applying our logical operators. Let me list out the logical operators. We have logical and, we have logical or, and not. So for example, if I say x and y, so this will be true if both are true and there is x or y. True if either x or y is true. And then we have not of x. Not can be applied to only one variable. So here I'll say it will change to opposite. That is true will become false and false will become true. Now let's have a look at the example. So here I'll say x equals 20, y equals 30. And then if I say print x equals 20 and y equals 30. So here it's going to check if the value of x is equals 20 and y is equals 30. If both of them are true, then the final output will become true because here we are applying and. So let me run the file and you see the output is true. Similarly, now I'll say print x equals 25 and y equals 30. So if you see here, y equals 30 is true, but x equals 25 is false. So the final output will become false because for and to be true, both the values should be true. Then only the final output will become true. So this should become the false. Now, if I say x equals 25 or y equals 30. So if you notice here, I'm applying or. For or, if either one of the condition is true, then the final output will become true. So x equals 25 is false here. but y equals 30 is true. So that's why I get the output as true. And let's say x greater than or equals 25 or y equals 31. So y equals 31 is false here. But if you check x greater than or equal to 25, x equals 25 is false and x greater than 25 is again false. So the final output will become false. And then lastly, if I say x equals 25 or y equals 31, and if I apply not to it. So we first have to evaluate the inner bracket, x equals 25 or y equals 31. So because here we have or, if either of the condition is true, then the output will become true. But x equals 25 is false, y equals 31 is false. When we apply not on false, that becomes true. So you see the output is true. So this is about logical operators. Now let's go and see what are identity operators. So identity operators are used to compare objects, not if they are equal, but if they are same objects with same memory location. So now what I'll do is here, I'll first list out the identity operators, that is and is not. And let's take a variable x and assign a list to it. X equals 1 to 3. Let's take another variable y and again create the same list having 3 elements, that is 1, 2, and 3. So now what I'll do is I'll simply go and say print x is y. Okay, because here if you see the elements are list elements. Both x and y are holding the list and having the same elements. Let's go and see what happens if I run. So let me run. And you see the output is false here. Though the lists are same, we are still getting the output as false, because if you look at the definition, it says identity operators are used to compare objects, not only if they are equal, but they are same objects with same memory location. So whenever we use directly is, this is not going to, it means that the memory location is not same here. Now, how do we make this memory location same is, what I can do is I can say something like y equals x. I'm assigning x and y to each other so that the memory location becomes same. Or let me say x equals y. And now see, now you see if I go and run, you see the output is true. So when I was doing x is y without assigning the variables to each other, it was giving me false because it was only checking for the elements, not for the memory location, right? So one more thing I can do is I can say z equals y. I don't know what z is, right? So, but I can go and check. I can say that y is z, and now when I run, you see I still get the same output true. All right. So what is does is it returns true if both variables are same objects, and is not returns true if both variables are not same objects. So here if I say is not, this would give me false. All right. So this is the only case with list. What if I have tuples? If I say T1 equals 1, 2, 3, and T2 equals again 1, 2, 3, I'll try doing the same. I'll say T1 is T2. So now because I'm using tuples, let's see what happens. So if I run, you see the output here is true For list, whenever I was doing x is y without assigning the variables to each other, it was giving me false. Because for tuples, it gives true because tuples are immutable and they remain fixed. That is why it gives true directly, and we don't have to assign the variables to each other. So this was about identity operators. Now let's move to the next operators, that is membership operators. Now this membership operator can be assigned or can be used or can be applied to all of the sequences like lists, strings, tuples, sets. So basically, membership operators are used to test if a sequence is present in an object, or if an element is present in the given sequence or no. I'm going to list them out. In and not in are my membership operators. So for example, if I create a list, let's say the list elements are hi, hello, and hey. And if I print, let's say hi in A. So what am I doing here? I'm checking whether this element hi is present in A or no. So let's go and check. I'm going to click on second run, membership operators. You see the output I get is false here because I'm checking for hi with single I, and I actually have hi with double I in my list. So that's why it's false. What if I say hello in A and run? You see, it's true. And then if I say hey, not in A, and if I run, you see this gives me false because hey is already present in my list. So this was about membership operators. Or another important thing here you can do is you can check for multiple elements at a time. For example, I want to check if hi and hello both are present. So I can say hi and hello in A. So and here means both. If both elements are present, then only it will give me true. Otherwise, it will give me false. And what happens if I write something like hey in A? So let's run and check. You see, this gives me this. Not checking if hey is present in my list A or no. Instead, I'm printing it in the form of a string. Now, this was about membership operators. Now, let's see what are bitwise operators. So here I'll say bitwise operators. So bitwise operators are used to compare binary values or binary numbers, that is zeros and ones. So I'm going to list out the bitwise operators. We have and, bitwise or, that is the pipe symbol. Then the caret symbol, that's bitwise XOR, and then we have this negation tilde symbol. So here, and will set each bit to 1 if both bits are 1, or will set each bit to 1 if one of the bit is 1, and XOR sets each bit to 1 if only one of the bit is 1. It means whenever the bits are same, the XOR will be 0. Whenever the bits are changed, the XOR will become 1, and the tilde is going to invert all the bits. For example, if I say A equals 60 and B equals 13. So what I'll do is, in order to make you understand, I'll just have a binary representation of 60, and we'll see how the internal implementation takes place. So let's say the value of 60 in binary 0011 and 1100. Then I have the representation of 13, zero 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 zero, and then we have 1101. So now I can directly say, or we'll do one thing, we'll have a variable C, and C equals A and B. And then we have print C here. So what I'll do is I'll try to see what output we will get. So on these two bits, we will apply the AND. So 00 will become 0, 00 will become 0, 10 is again 0, 10 is 0, 11 is 1, because for AND, if both the bits are 1, it will become 1. 1100 0. So now we need to add up the bits where we have 1. So this is your 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So 2 to the power of 2 is 4, plus 2 to the power of 3 is 8. So the output we should get is 12. So I'll go and run. Now you see the output is 12. So this is the internal implementation of A and B. That is A bitwise operators B. Similarly, if I try doing C equals A or B and then print C, let me write here, this is 12. Okay, now we'll apply OR. So for OR, if either one of the bit is 1, the output will become 1. So 0 0 is 0, 0 0 is 0, 1 0 is 1, 1 0 is 1, 1 1 is 1, 1 1 is 1, 0 0 is 0, and 0 1 is 1. So here it is 2 to the power of 0 is 1, plus 2 to the power of 1 is 0 here, 2 to the power of 2 is 4 plus 8, and then plus 16 plus 32. Let's go and see the output. So you see the output here is 61. All right. Now, similarly, if I try XOR, C equals A XOR B, and then print C. Let me check the bits. So for XOR, whenever we have different bits, it will become 1. So 0 0 0 0 0 0, 1 0 is 1, 1 0 is 1, 1 1 is 0, 1 1 is 0, 0 0 is 0, 0 1 is 1. So the output I'll get is 1 plus 16 plus 32. And when I run, it's 49. So this was about XOR. Now, lastly, for till, we will apply negation to only one. If I say C equals negation of A and print A. So whenever you are trying to do the negation, you have to make use of either ones or two's complement. So if I do the negation of A, so it will be 1 1 0 0 0 0 1 1. So if you try calculating the bits like I have calculated previously, it will give you some greater value, because here 2 to the power of 7 is 1. But if you go and check the output, that will be sorry, this should be 1 second. Sorry, it should be print C and not print A. So now when I run, I get the output as minus 61. So this was about bitwise operators. I hope you understood operators in Python. All right. So the next topic that we are going to see is lists in Python. So in this, we will be learning about Python list. We'll see how to create a list, how to access list elements or items, and we'll see what are list methods that Python has support for. So we'll see how to create a list. So we know that list is a collection which is ordered and changeable. So here changeable means it is mutable in nature. We can create the list and we can change the list at any moment of time. And list can store any number of values dynamically, and it maintains order of them, and it allows duplicate elements. And also list is heterogeneous data type. It means it can hold data from different data types, like it can hold strings, integers, negative integers, floating point values, Boolean values, and so on. And lists in Python are written in square brackets, and we can find the length of list using the len function or len method that is going to return the total number of elements present in a list. Now let's see how to access list items or elements. So list items can be accessed using indexing. Indexing here is nothing but a concept of reaching out to a particular item or element in a list. Because list is a sequence, we can perform indexing on it because elements will be sitting at different index positions or specific index position. And indexing starts from 0 and goes up to length -1. And we can also perform slicing. So slicing is based on indexing only, and it is used to access multiple items from the list. Indexing is going to access only one element or item from the list, whereas slicing is going to access multiple items or elements from the list. Now let's see list methods. So Python has support for many list methods that are built in, that are already available. So using list methods, we can add and remove elements to and fro from the list. Let's talk about the elements using which we can add, methods using which we can add elements to the list. First one is append, that is going to add one single element to the end of the list. Then we have insert, that is used to add an element to specified index position. And then we have extend that is going to add multiple elements to the end of the list. And then using remove, we can remove one single element or actual element from the list. And pop is used to pop or remove the last element from the list. Or we can also specify index to the pop, using which the element at that specific index would get popped out. Now let's hop to the PyCharm and see how we can create the list, access the list items, and then perform these list methods. Now here over the PyCharm, I'm going to right click on the project name, create a new Python file, and name this to be lists. So we need not name the file as list because list is a built-in. So I've written lists. Let me say list is a sequence or a collection which is ordered and mutable. Mutable here is it is changeable. Now let's go and create a list. So I'll first create a list variable, list. So if you see, this list is built in, so we need not write the name of the variable as list. So I'll just skip this I, and let's say the variable name is lst, and print is lst, and also check the data type of it. So if you see here, there are no elements in our list. So let's run and check what output it gives. There we go. You see, this gives us the empty list. Now to the same list, I'm going to add some elements inside the square bracket. So let's say 10, 20, 30, Python -10, and 35.5 are my elements. And now I'll say print list. And you see, this list is heterogeneous because it holds the data of integers, string, negative integer, and floating point value. Now we'll try doing indexing on this list. So as I already mentioned, indexing starts from 0. So it means that the index position of 10 is 0. So 10 is at index position 0, 20 is 1, 30 is at 2, Python is at 3, and so on. Now, if I say LST square bracket, then mention the index position, it should return the index position element at that particular index position. So now when I run, you see the output is 10. Similarly, LST of 2 should give me 30, and you see the output is 30. And indexing can also be done from a right-hand side, but indexing from right-hand side starts with negative value. So it means 33.5 is at index position -1, -10 is at index position -2. So if I go and write -2, this is known as negative indexing, and I get the output as -10. If I say print LST of, let's say, 7 and run, you see this gives me an error list index out of range because the last index position that we have is 0, 1, 2, 3, 4, and 5. Anything greater than 5 would give me an error. So I'm going to comment this. Now let's see what slicing is. So for slicing, we need to make use of the slice syntax because here we are going to print multiple elements at a time. So the slice syntax makes use of the start index, let's say 0, followed by colon, and the end index, let's say 4. So this slice syntax should give me elements from 0 to 4, including 0, but excluding 4. It means from 0 to 3, elements that are at index position 0 to 3. So it should be 0, 1, 2, 3. So it should give me the output 10, 20, 30, and Python. You see the output is 10, 20, 30, and Python. The higher index is always excluded. So it is anything between lower index or start index and higher index or end index, including the start index, excluding the end index. I can also do the slicing with negative indexing. So I'll say -3 colon -1. Anything between -3 and -1, including -3, excluding -1, is Python and -10. Let's run and check. And you see the output is Python and -10. Now I can just write colon and say 4 and run. So here, if you see, this gives me the output 10, 20, 30, -10. I haven't specified the start index, but I've specified the end index. So it will by default start from the very first. And here, if I say 3 colon, I have specified the start index, but I haven't specified the end. So it means it will start from 3 and print all the other elements after 3. So that's why it gives Python -10 and 33.5. Now let's see what are list methods. So the first method we have is append, that is going to add one single element to the list. So I'll say lst.append. Let's say I want to append the element 40. When I print lst, so it should add element 40 to the end of my list. So you see 40 has been added. What if I want to have an element added at specified index position? Then I can make use of insert. Insert will take two arguments. One is the index position and the other is the element that is to be added. So lst.insert. Let's say I want to add 50 after 10. So that becomes index position 1, right? So I'll say 1, 50 and lst. And you see 50 has been added after 10. Now, what if I want to add multiple elements to the list? I can make use of extend, but these elements would get added at the end of the list. And whenever you have to add multiple elements, you should make use of square bracket. Let's say I want to add 1, 2, 3 to the end of the list. And now when I say print list, you see after 40, I get 1, 2, and 3. So this was how we add elements to the list. Now let's see how we can remove elements from the list. So using remove, we can remove the actual element. For example, if I want to remove the element 20, so I can directly go and say lst.remove, print lst, and run. There we go. You see 20 has been removed from the list. Now let's see how we can pop. So here I'll say lst.pop. So pop will remove the last element as it is LIFO, last in, first out. So now when I run, you see the element 3 has been popped out. You can also use pop to remove the element at specified index. So I can say lst.pop and mention the index position at which the element is present has to be removed. So when I say 1, this doesn't mean this 1 because here 1 is the actual element. So I can say print lst now. So this should remove the element 50 and not the element 1. Now you see 50 has been popped out because this is the index position, not the actual element. So this is how we can add and remove elements from the list. I can also go and do for delete. So delete lst of, again here I need to mention the index position. Let's say I want to delete the element at index position 4. And now when I go and see the element 35.5 has been deleted. I can also find maximum and minimum element from my list. So I can say print max of LST and print min of LST. So this should give me 40 and minus 10. Let's run and check what output it gives. So you see, it gives me an error saying type error, this greater than operator does not support between instance of string and list. Why is that? Because in our list, we have a string called Python. So if I want to find the maximum or minimum elements from my list, I just need to first remove that. So what I'll do, I'll say lst.remove. I'll remove the element Python, then print the list. And now when I go and run, it should give me the maximum element to be 40 and minimum element to be -1. Yeah, hello everyone. Welcome to HKR trainings. In this session, we will be learning about dictionary in Python. Now let's get started. So dictionary is a collection which is unindexed and mutable. Now, why do we say that dictionary is unindexed? Because we do not use numbers as index positions here. We only make use of keys as index. That's why we say dictionary is unindexed and mutable. The meaning of mutable here is it can be changed at any point of the time. And dictionary is a map, which is a key value pair. So basically, dictionary stores the element or item in the form of key value pair that is separated by a colon. And in Python, dictionaries are written using the curly brackets or flower braces. Now let's have a look at the syntax of dictionary. So here we have dict1 equals and then opening flower bracket 1 colon John. So if you see 1 here is the key and then followed by colon and then John is its associated value. And if you see here, the key and value pairs are separated by colon. Now let's see what conditional statements are. So conditional statements are part of flow control statements or decision-making statements or control flow statements. So flow control statements determine the order in which statements are executed at runtime. We have 3 types of flow control statements. First one is conditional statements. So in conditional statements, we have if block, else block, and elif block. If block is basically going to check the condition. And if the condition evaluates to true, then it is going to execute the body of if block. Then we have else block, which will not have any condition to check. Whenever the if block is failing, then the control goes to the else block. And then we have elif block. So whenever we have multiple conditions to check, we go for elif block. So we can only have one if, multiple elif, and then else block in conditional statements. Next, we have looping statements. So in order to move over or iterate over elements in any sequence, we make use of for loop and also while loop in order to check some Boolean condition, and it evaluates to true until the condition remains true. Then we have transfer statements that is basically going to transfer the control from one place to another place in the program. We have break, continue, and pass as keywords for transfer statements. Now, conditional statements execute until condition remains true, and the syntax of these flow control statements make use of colon and indentation. Now, let's see what are loops in Python. So Python has two primitive loop commands. One is for loop and the other is while loop. So objects in Python are iterable. The term iterable means to move over or iterate over any elements in the sequence. And for loop also makes use of colon and indentation. Basically, for loop is going to be used when we have any iterations to perform. And then while loop evaluates to true until condition remains true. So once the condition is evaluated to false, the while loop is automatically terminated. So now let's talk about for loop. So objects in Python are iterable. The term iterable means to iterate over every object or every element in the sequence. The sequence can be anything like string, list, tuple, sets, dictionary, and so on. We can use for loops to execute block of code for iteration, and a for loop is used for iterating over a sequence. Now let's have a look at the syntax of for loop. So we have a sequence variable, my underscore sequence equals, here I've taken an example of list, and this list is having 3 elements. It means this particular loop is going to run for 3 times. And then we have for keyword followed by iteration variable in the sequence variable, and then we are going to print this iteration variable. So you can take iteration variable as anything num, I, j, k, item, element, whatever you want. Now let's talk about while loop. So with while loop, we can execute set of instructions or statements as long as the condition is true. Once the condition is evaluated to false, it automatically terminates the while loop. Let's have a look at the syntax of while loop. We have while keyword followed by some Boolean condition. It means here we will check for a variable to be greater than or lesser than some number, or greater than or equal to some number, and so on. If this condition is true, then the control goes inside the while loop. While loop basically has 3 important steps: initialization, condition, and then incrementation or decrementation based on the condition. Now let's see what are functions of Python. So functions are nothing but group of statements that perform a specific task. A function is a block of code which only runs when it is called. If you're not calling the function is never executed. And then we can also pass data to the function in the form of parameters or arguments. And a function may or may not have the arguments, and function can return data as a result. Now let's see how we can define a function. Let's create a function. In Python, function is defined using a special keyword known as def. Def here stands for function definition. Now let's have a look at the syntax. We have def keyword followed by function name and then parenthesis colon. In this parenthesis, if we have any arguments or parameter to pass, we can pass those. As I already mentioned, a function may or may not have the arguments. So this function is not having any argument. And then we have the code or statement that is forming the function body. Now let's see what are lambda functions. So a lambda function is a small anonymous function. It can take any number of arguments, but can only have one single expression. Lambda has a specific syntax that we need to follow. Let's see the syntax of lambda function. So here we have f equals lambda a colon a into a. So here f is nothing but the function object that accepts and stores the result of expression, or you can, in other words, say that it is a variable that is holding the output of the lambda function. And then we have this lambda keyword. So if you see here, we do not have a def keyword or a name to our function. That is why we say that lambda is anonymous, meaning it is not having any name. So lambda keyword, and then this a here is argument. So argument list will be followed by the lambda. You can have as many number of arguments you want. And then we have this expression. And the argument list and expression is separated by colon. An important thing to remember here is that we can have any number of arguments, basically list of arguments, but only one single expression. So now let's hop to Python and check out the example of dictionaries, conditional statements, loops, and functions in Python. Now here I'm on the Python. So I'm going to right click on the project name, go to new Python file. And here, let's first create a file by name dictionary. Now let's see what dictionary is. Dictionary is a collection which is mutable and unindexed. And it's a key value pair. Now let's go and create a dictionary. So dictionary is created using a flower bracket. So if I say D, you need not write the dictionary variable name as DICT because DICT here is a built-in. So I'll just make use of D. D equals flower bracket. If I say something like 1 colon, let me take the same example, 1 colon John, comma 2 colon, let's say Sam, and then 3 colon, let's say Bob. And then I'm going to print this dictionary D. Also check the type of it by writing print type of D. So if you see here, 1, 2, and 3 are the key of dictionary, and John, Sam, and Bob are their respective values. And all the key value pairs are separated by colon. And the elements here are separated by comma. So let's run and check the output. So I'm going to click on the second run, dictionary. And you see the output is dictionary, and the class here is text. So now we'll see how we can access the dictionary items. So here I'll say accessing dictionary items or elements. So as I already said that it is unindexed, meaning we cannot make use of numbers as index positions here. If I try doing something like print D of 0 and run, you see this gives me an error, key error, because we cannot make use of numbers in order to access the dictionary elements. Now, in order to access dictionary items or values, what you have to do is you have to here mention the name of the keys. So if I want to access this value, or let me say accessing dictionary values, here if I say 1, because 1 is my key name, and now when I go and run, you see I get the output as John. If I say print D of 3, I get the output as Sam. Now, if I want to change this dictionary, let's say I want to change value of this particular dictionary. So how do we do that? For example, I want to change the name Sam to, let's say, Steve. How do we do that? We first need to have print, or we'll first take D, that is name of dictionary, and then the key of Sam, that is 2, equals, and then assign the new value to it, Steve. And now when I go and print my D, now you see the output is 1 : John, 2 : Steve, and 3 : Bob. So this is how you can change dictionary item. If I want to add one more item to dictionary, add an item to dictionary. So if you want to change the item, you need to keep the key same. If you want to add a new item, you have to take another key. So I'll take 4 this time, equals, let me assign a name, Tina, to it. And now when I print D, if you see 4 : Tina has been added to the end of the dictionary. Similarly, if I want to access both keys and values together from my dictionary, so I can just go and say print D dot items. Items are collectively key and value pairs. So now when I run, you see the output is dict underscore items, 1 John, 2 Steve, 3 Bob, and 4 Tina. So this was about dictionaries. Now let's go and see what conditional statements are. So I'm going to create a new Python file here. Name this to be conditional statements. Hit enter. Now what conditional statements are? Conditional statements will evaluate until condition remains true. So the first conditional statement, I'll just list out the conditional statements here. We have if, we have else, and then we have elif. So the syntax of if is something like this. We'll have if keyword followed by the condition. So let's say I'm going to check if 1 is less than 2, and then print something like yes. So if this condition 1 less than 2 is true, then the control moves or goes inside my if block and I get the output as yes. So let's run and check. So I'm going to quickly run conditional statements and you see the output is yes. Now, what if I reverse the condition? If I say something like if 1 is greater than 2 and then print, if I say something like hi, so you see here I get a slight discoloration because the condition here is evaluating to false. So it means I should not see the output hi. So you see the only output we have is yes. Now, what if I make this a nested if and let me change this condition to something like 3 is greater than 2. Yeah. So now see what happens. If 1 less than 2 is true, then it should print yes. If 3 greater than 2 is true, then it should print hi. So now when I go and run, you see the output is yes and hi because both the conditions are satisfied. This is outer if and this is inner if. Now what happens if I change this condition? So you see 3 less than 2 is false. That's why I get only the output as yes. Now I'll change this condition back to 3 greater than 2, but here I'll reverse my condition. So here I'm checking if 1 is greater than 2, it should print yes. But if you see at the inner if, I'm checking 3 greater than 2. Though this condition is true, but you can see here there is a slight discoloration indicating an error, right? So in this case, you see I don't get any output. The reason is because this is a nested if. It means whenever we have nested if, the outer if should be true, then only you can execute the inner if. If the condition at outer if is evaluating to false, then you cannot run the condition at inner if, even if it is true. So this was about if. Now what happens if I say if 1 is less than 2, print hello, or let me say if block, and then I'll have else. Else will never have a condition to check. Whenever the condition if is failing, then the control moves to else block. So now here I'll say this is else block. And now when I go and run, you see the output I get is if block because the condition 1 less than 2 is true. What if I reverse this condition? When I say 1 greater than 2, if condition is failing, that's why I don't get the output as if block. And the control goes to else block. Else will not have any condition to check. So whatever is inside the else body would get printed. So now when I go and run, you see, I get the output as else block. Now, if I say something like if 2 is greater than 3, okay, let me say if block again. Now, I want to check one more condition here. Let's say elif. And this time I'll say 3 equals 3. And then print here I'll say elif block. And then else. Print here I'll say else block. So the condition at elif is evaluating to true. That's why I get the output as elif block. All right. But what happens if both if and elif are evaluated to true? So if you notice here, if I say 2 less than 3, okay, and if I run, now you see I get the output as if block. Though the condition at elif is true, 3 equals 3, this is not evaluating because either of the condition would get evaluated. It means if both if and elif are true, then only the output of if will be printed. Only if the condition at if is failing and the condition at elif is true, then only you can see the elif block getting evaluated or printed onto the console. So this is when you have multiple conditions to check. elif not only checks a single condition, you can check many conditions using elif. For example, if I say name equals John, and here I'll check if name equals something like Sam, and then it should print hi Sam as the output. And then I have elif that checks for name equals Bob. If this is true, then it should say hi Bob. Similarly, if I have elif name equals John, print hi John, and then another elif that says name equals Tina, print hi Tina, and then lastly we'll have an else block that says something like print what is your name. So now try answering this question. So here I've assigned the value John in a variable name, and I'm checking if the value is John, then it should print hi John. So let's go and check what the output it gives. So you see the output it gives is what is your name. So now whenever you look at the code, you would directly say that it'll print this line number 27, hi John. But why is it printing this else block and giving us the output what is your name? The reason is here I'm using capital J. The variable value starts with capital J, and I'm here checking for the small j. So if I want the output to be hi John, I can just go and change this to caps J. And now when I go and run, you see the output is hi John. So because the variables are case sensitive in Python, it was giving us this else block output. So this was about conditional statements. We have also seen the multiple elif ladder. Now we'll go and see what for loop is. So I'm going to create a file by name for_loop. And let's say for loop. So for loop is mainly used for iteration. The syntax of for loop is we will first have some lists created over here. Any sequence, I'm going to take a list. Let's say my list equals, these are my list items. Now I want to iterate over this list. That is, I want to print the numbers 1 to 5. It's not a compulsion that these numbers should be sequential. You can take any numbers like 1, 2, 10, 12, 20, 100, anything you want. And then you have to write for, followed by the iteration variable. You can take anything as iteration variable here. Let me take I. For I in my list colon. See, as soon as I write a colon and hit enter, it automatically takes the indentation. And now, if I print I and run, sorry, I need to select the file to run. So now you see the output is 1, 2, 3, 4, 5. So this loop is running for 5 times. Now, same thing if I say something like for j in my list colon print hi. So now let's see what happens. Here, if you see, the iteration variable is j, but instead of printing j, I'm actually printing hi. So this is actually valid. This is not invalid. So what will happen here is this j, that is the iteration variable, will be pointing to these elements of the list. In the first iteration, j will be pointing to 1. Instead of printing j, I'm printing hi. In the second iteration, j will be pointing to 2. Instead of printing j, I'm printing hi. And this goes on until the last element of the sequence, right? So what should happen now? J will be pointing to these elements, and instead of j, I'm every time printing hi. It means hi should be printed for 5 times because our list is having 5 elements. So now when I go and run, you see the output is hi, hi, and hi 5 times. So this is how you make iteration over the list. If I want to, let's say, sum up the elements of this list, I can do that as well. Let's say sum up list elements or items. So how do we do that? I'll take a variable, let's say sum equals 0 first. Or let me take list sum equals 0. And then I can run the loop, let's say for num in my list. Here I can say list underscore sum equals list underscore sum plus num. And then inside the for loop, if I'm printing the value of list sum, it should give me the output of each and every iteration. So for example, the list sum value is 0 for the first time equals 0 plus the value of num. First value of num is 1. So 0 plus 1 becomes 1, right? Equals 1 plus second value is 2. So this becomes 3. This is only for the understanding purpose. 3 plus 3. So if you see, the num value is ranging from 1 to 6. It will range from 1 to 6, 1 to 5 because the last element is 5, right? So this will be 6 equals 6 plus 4. And then you have 10 equals 10 plus 5. So the last value you get is 15. So we are basically trying to get the same value. So now if I go and run, you see you get all the iterations 1, 3, 6, 10, 15, whatever I have written. If you want only the output, that is the final output 15, then you need not write your print statement inside the for loop. You just come out of the for loop, and here you can write print list underscore sum. So now when I run, you should see it only gives me the output 15. If you have both the print statements, then you should see the 15 element printed twice. One from the inner print statement and one from the outer print statement. Similarly, I can also go and check if my list is having any even numbers or so. So here I'll say check for even numbers in my list. All right, so what I'll do is I'll say for I in my list. All right, so in order to get the even numbers or print the even numbers from the list, we need to write a condition for even numbers. That is, we need to check for divisibility by 2. So here I'll say if I mod 2 equals 0. This condition is used to check if a number is even or no. All right. So now here I'll say something like I comma is even. So I is basically my number, or it is an iteration variable that is going to be pointing to the numbers, right? So I'll copy this list again here for reference. Or I'll say my list equals 1, 2, 3, 4, 5. Okay. So now see what happens if I run. You see it gives me output 2 is even and 4 is even. So because the first element is 1 and the condition here is not satisfying, it's not printing 1. For 3 also the condition is not satisfying. That is why it is not printing. Now you can iterate over strings. So I'll take a string, let's say my underscore string. This is a variable equals, I can say something like hello world is my string. So I'll write the for loop to be, let's say, for letter in my underscore string colon print. Here I will print the letter. So let's run and check what happens. You see the output is hello world. And now what if I want this hello world to be printed on one single horizontal line? So how do I do that? Here I can make use of n command, and let's say n is equal to space. So what will happen after each and every iteration? It will be ended with a space. So now when I go and run, you see the output is hello world. All right. Similarly, if I say something like for letter in Python colon, if I say something like print hello. So what should happen here? First, we will check if this is valid or no. So here, if you notice, this hello world string is saved in a variable or stored in a variable called my underscore string. And here, I'm not storing Python in any other variable. I'm directly iterating over the string. So that is also possible. You don't have to write an extra variable over here. And every time this letter is pointing to elements of the string Python, let's say for a letter will be pointing to P in the first iteration. Instead of printing P, it should print hello. In the next iteration, instead of printing Y, it should print hello. Instead of in the next iteration again, instead of P, it should print hello. So hello will be printed 6 times. Let's go and see the output. Now you see the output is hello has been printed 6 times. And another thing, if you notice here, is the first hello is overlapped with the previous output. So it's combined or joined with the previous output. The reason is one of the use of end statement is to end with whatever is specified over here, and the other is to join two print statements. So whenever you use end in your print statement, the very next line, you can just go and write an empty print statement. So this will create the space between the two outputs. So now when I go and run, you should see the hello should be shifted to next line. This hello that was initially here or earlier here is now has been shifted to hello because of this empty print statement. Now let's see how to iterate over tuples. So I'll say something like T1 equals 1, 2, 3 for I in T1. I'll say print I. So this should just give me 1, 2, and 3 as the output. All right. We have we have a concept known as tuple unpacking. For that, what we will do is we will create a list of tuples. So list of 1, 2, 3, 4. So this 1, 2, 3, 4 are the pair of tuples. And here I'll say 5, 6 and 7, 8. So if you notice here, each and every tuple is holding pair of elements. We have only 2 elements inside the tuples. I'll print this list and also check the type of list, as well as I want to know the length of list. That is how many elements this list is holding. So I'll go and do print len of lst. Len should return the total number of elements inside the list. So now when I go and run, you see the output here is class list and the total number of elements are 4 and not 8. That is to be remembered. This pair of tuple is one single element of our list. Now let's do the iteration. If I say for I in lst colon print I and run, so you see we get the output as pair of tuples 1, 2, 3, 4, 5, 6, 7, 8. Now what I want is I want to unpack these tuples. By unpacking, I means I have to remove these elements out of the tuple brackets. So how do we do that? Because each of the tuples are having a pair of elements. So what I'll do is I'll make use of 2 variables in order to iterate. So I'll say for T1, T2 in LST. And then here I'll say print T1 and in the next line print T2. So now when I go and run, you see the output is 1, 2, 3, 4, 5, 6, 7, 8 in different lines, and we do not have the pair of tuples. Now what happens if I say T2 and T1? So here T1 will be pointing to the first element. So this will become your T1. 1 is T1, 2 is T2, 3 is T1, 4 is T2, 5 is T1, 6 is T2, 7 is T1, and 8 is T2. So now when I first print T2 and then print T1, so it will be 2, 1, 4, 3, 6, 5, and 8, 7 as the output. It's not going to be 8, 7, 6, 5, 4, 3, 2, 1. So this is how we unpack the tuple elements. Now, let's say I have to iterate over the set. So I'll say iterate over set. I'll create a set, let's say S equals. Set is also written in flower bracket. So I say 1, 2, 3 are my set elements. I'll say for I in S. And then when I say print I, let's run and check what output it gives. So you see the output is 1, 2, and 3. Also, we can iterate over the dictionary. So here I'll create a dictionary. Iterate over dictionary. So here I'll create a dictionary. Let's say D1 equals, let's say the dictionary is brand colon BMW, model colon, something like, this is to be like this, model colon 3 series, and then year colon something like 2018. So I'll say print D1 and run. You see, this is the dictionary. I have to iterate over this. So I'll say for I in D1. And now when I print I, this will only give me my keys, that is brand, model, and year. If I also want the values, so here I'll say print the dictionary name of I. So this will give me values. So the output will become brand BMW, model 3 series, and year 2018. You can also make use of keys and values built-in function, or you can also make use of items function to iterate over both keys and values at a time. Now let's say I want to display numbers from 1 to or let's say I want to display numbers from 20 to 50. So what I'll do here is I'll make use of for I in. Now, whenever we say we have to print numbers from specific number to specific number, it means from 20 to 50 here is a range, right? So I'll make use of range function and say the start of range is 20 and the end of range is 50. And then I can say print I. So range will include the first item and it will exclude the last item or end of the range. So it will print from 20 to 49. It will not print 50, isn't it? So now what if I take the same and this time I give a step value of 2. So this will print alternate numbers. It means it will print 20, 22, 24, 26, 28, so on up to 48. The reason why it is printing alternate number is 2 here is the step value. It's not a compulsion that step value will always give you even numbers. It mainly depends on the start of the range. If your range starts with odd number, then it will print odd numbers. If your range starts with even number, then it will print even numbers. So you see the output is from 20 to 48. If you want to see on one single line, you can just go and write and equal space here. And now you see the output is 20 to 48. So now let's say we have to print multiplication table of a given multiplication table of a number. Multiplication table of a number. So now let's see how we can do that. So what I'll do is I'll first try to get the number from the user using the input function. So here I'll say x equals input. Because I'm talking about number, I need to first typecast this input function into int, because input function by default accepts only string values. Now here I'll say something like enter a number. And then here I'll write my for loop. I'll say for I in range. Because I want to print the multiplication table, it means I want to print from 1 to 10. So I'll take the range to be 1 to 11. And then here I'll say print I into x, isn't it? Because I will be ranging from 1 to 10. X is the number that we are taking from the user. So also I have to write an empty print statement here in order for the outputs to separate. So now when I go and run and say 2, you see the output I get is 2, 4, 6, that is 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, so on up to 2 10s are 20. If I actually want to print that in the form of a table, so I can say for I in range, only the print statement changes here. So in print statement, what I'll do is I'll say print x, caps x, whatever I'm writing inside the quotation would get printed to the console. So I also want to have an equals, and then either I can write I into x or x into y. So I'll write I into x. So this is my number. This is the into symbol that is written in the form of string. Then we have I that is ranging from 1 to 11. That is, it will print 1 to 10. Equals again will be printed to the console, and I into x will be the computational value. So now when I run and say 2, you see this is how our multiplication table looks like. Right. So this was about for loops. Now we'll go and see how we can make use of while loops. So I'm going to create a new Python file and name this to be while loops. So while loop While loop evaluates until condition remains true. So what does it mean? It means that until and unless the condition is false, then the while loop will be continuously running. For example, if I say while x less than 5 colon, here is the while keyword and followed by Boolean condition. And then I want to print the value of x. Let's see what happens if I go and run this. So I'll go to run, click on my run and click on while loop. So you see, I get an error here saying name error, name x is not defined. Obviously, because x is a variable to which we have not defined the value, we have not initialized the value. That's why it gives me an error. So the very first step of in while loop is initialization of variable. So here I'll say x equals 0. So this is the first important step that is known as initialization. And then here we have condition to be checked. Now let's run and check what happens. So if I run, you see what's happening. It's giving me 0, 0, 0, 0 continuously. So I'll just simply quickly stop it. Otherwise, it might crash my PyCharm as well. So now another important step here is that I need to increment the value. Incrementation or decrementation depends on the condition. So here I want to increment the value of x by 1. That is as good as telling x equals x plus 1. And this step is also known as incrementation. And now when I run, you see the output is from 0 to 4 because I'm checking for x less than 5. So it means it will start from 0 and it will end by 4 because I'm checking for x less than 5. If I also want to print 5, then here I need to give x less than or equals 5. Now, similarly, if I want to print numbers from 1 to 20 using while loop. So here we first need to see what is the start in order to initialize the value. So I'll say I equals 1. Okay, then while x is less than 21. I could either say x less than 21 or x less than or equals 20. That should also work. And then here I'll say print. Sorry, this is I and not x. I. And then print I and also increment the value of I plus equals 1. So now when I go and run, you see the output is, it's printing numbers from 1 to 20. Now, similarly, if I want to get the output in this way, let's say 5, 4, 3, 2, 1. I want to print the series of numbers. It's decreasing, it's in decreasing order. So how do we do that? We first need to initialize the value of variable. Let's say x equals 5. Okay, because I want the number to be, first number to be printed as 5. And then I can check for the condition. Let's say while x is greater. This time I have to check for the greater because the value I'm using is greater here, right? Because I'm actually trying to print in decreasing order. So here I'll say if x is greater than 0 because the last number here is 1. Or you can say x greater than or equal to 1 equals. And then here I'll say print the value of x. This time we have to decrement the value of x and not increment because the condition we are checking is reverse. So here I'll say x minus equals 1. All right. So let me quickly run and check if this gives me the output 5, 4, 3, 2, 1. So you see the output here is 5, 4, 3, 2, 1. Again, if I want in one single horizontal line, I can simply go and say end equals space. And now when I run, you see the output is 5, 4, 3, 2, 1. So we don't have a lot of things in while loop except for these 3 important steps: initialization, condition, and incrementation. So whatever code you write, you're going to write the same. But if you ever come across while true, if you try giving your Boolean condition true, so it means inside the while loop, you have to compulsorily make use of break statement in order to voluntarily break your while loop. Right. So now let's go and see what are functions in Python. So I'll create a file by name functions. And here I'll say something like functions are group of statements that execute block of code, or you can even say particular instruction or specific instruction. Now functions can be built in or user defined. Now what are built-in function? I'll write the example of built-in function. We have this print function that is built in, that is going to print to the user console, or it's going to print whatever we write inside the print statement. And then we have input. Input basically allows the user input. Now, when we have any computation to perform, we mainly go for user-defined functions, like we have any processing to do or calculations to perform, then we go for user-defined functions. Now, how do we write the user-defined function? We need to define the function using the def keyword. So for example, let's say I have to create a function. So I'll first start with the def keyword. Anything that starts with def in Python is a function. But if you make use of the same functions in object-oriented programming, you call those functions as methods in object-oriented programming. But if you're not using object-oriented programming concepts, then anything that starts with def is a function. It's a user-defined function. For example, if I say def greet followed by parenthesis colon. So def is the function definition followed by name of the function. Greet here is name of function followed by parenthesis. Parenthesis here is given because if we want, you can add arguments or parameters to the function, but a function may or may not have the arguments or parameters. So I'm not passing any arguments to it. Simply what I want is I want to print some greeting here. Let's say print hi and print hello. So now if I run and check, let's see what happens. If I run, you see the output is nothing. I don't see any output over here. Okay, the reason why we don't see the output here is that we are only defining the function and we are not actually calling it. So here I can go and call the function greet. This is calling or invoking the function. Calling or invoking the function. And now when I run, you see the output is hi and hello. So again, I can go and say greet and run. You see the output is once again hi and hello. So the main use or advantage of function is that it is mainly used for reusability. That is, you can write your function code once and call it as many number of times in the same file or in different file. Now let's say I have to write a function to add two numbers. So here we'll make use of function arguments. Let's say def add is name of the function that takes two arguments, a and b. Because here we want to add two numbers, we need to pass two arguments over here. And here I'll say c equals a plus b inside the function body. And I can say print c. I can directly write print a plus b also, and then call the add function and pass the values to the arguments, let's say 10 and 5. So A will become your 10 and B will become your 5. So now when I go and run, you see the output is 15. Similarly, if I want to call this function passing different values, let's say 3 and 4, and now when I run, you see I get the same output again, that is 7. Now let's say I have to write a function to find average of two numbers. So how do I do that? Def, let's say avg is name of the function that takes two arguments, let's say a and b. Here, instead of taking c equals a plus b by 2, I'll directly take a plus b whole divided by 2. And then I'll call the function avg and pass the value, let's say 10 and 20. Because this is a print statement, we also need to write the bracket of print statement. And now when I run, you see the output is 15. I can also go and say something like average of two numbers is colon, comma, and run. You see the output is average of two numbers is 15. I can also write the string inside my print statement. Now, what if I say that functions can execute or return back some result? All right. So let's say I have to write a function to return sum of two numbers. So what I can do here is I can say def sum and let's say a comma b. And here I will say something like c equals a plus b and then return c. So if you notice here, I'm not making use of the print statement. Instead, I'm making use of the return keyword here. So now when I go and say sum and pass the value like 2 and 3, expected output is 5. Let's run and check. So you see, it doesn't give me any output, right? The reason here is that inside our sum function, we do not have any print function to display the output, right? Now, how do I display the output? I can call the sum function inside my print function like this. And now when I go and run, you see the output is 5. Or I can do one more thing here. I can take another variable and call the function this way, let's say 3 and 5. And then I can go and print the variable result. And now when I run, you see the output is 8. Similarly, if I want to write a function to return average of two numbers, so here I'll say def average. Let's say average is name of the function that takes a and b as the argument. And here I'll directly say return a plus b whole divided by 2. And then I can go and use print statement to call the average function and pass the value 10 and 20. So now it should give me 15.0 as the output. Now, another important thing is that functions can return multiple values. Now, how do we say that functions can return multiple values? So let's create a function. Let's say calc is the function that takes a and b as the argument. Basically, this calc function will perform 4 operations, arithmetic operations. Let's say x equals a plus b. That is addition. Y equals a minus b. That is subtraction. Z equals a into b. And then u equals a divided by b. Now we have to return this. Now, important thing to remember here is that we have to return all these variables x, y, z, u in one single line, followed by the return statement. You don't have to write your return 4 times, like return x, return y, return z, and return u. You shouldn't have to do that. It'll give you an error. Now, so what we will do is we'll directly call our calc function and pass the values like 10 and 5. And now let's see what output it gives. So now when I run, you see the output is a tuple that is holding the addition, subtraction, multiplication, and division of these values, right? Now, what if I want to unpack these tuple elements? I can directly make use of for loop this way. For I in calc of 10, 5, and then colon print I. And now when I run, you see the values have been unpacked out of the tuple. Or I can also go and make use of result. Result equals calc of 10, 5. And then I can say for I in result, colon print I. It should also give me the unpacked output. All right. So this is how functions can return multiple values. Now let's go and see what actually function arguments are. So I'm going to create a new Python file here, name this to be function underscore arguments. So let me write an example here. Let's say def my func is name of the function that takes x as an argument, inside which I'm having a variable called x. Let's say x is 5, and I want to print the value of x. I'll say x is colon comma x. And then here, I'll call my function, like let's say my func, and pass value 6 to it. So normally what happens is the execution starts from line number 6. That is when we call the function, the function execution begins. So this function will take x as an argument, because x we have as an argument here. And inside the function, we have a variable again by name x. So what will happen? Let's go and check. So now when I run, you see the output it gives us x is 5 and not x is 6. The reason is because the argument name and the variable name is same here. Now what I'll do is here I'll write a user-defined function to update some sequence, let's say list. So what I'll do is I'll first go and check the ID of my list. So I'll say print ID of list. I want to check the address of my list variable, and I also want to modify one of the element of my list. So here I'll say list of 1 equals 25. I don't know what elements my list is having right now, but I want to change one of them. I want to change the element at index position 1, and then I'll say print ID of LST. Okay, and then here I'll say print something like LST is colon comma LST. And then I'll call my update function. So here I'll say update. Before that, I could write list equals the elements, let's say 10, 20, and 30. And I can pass this list. Or I can directly pass my list elements using the square brackets here. So now when I go and run, so you see the address is same before and after modification of the lists, and the list elements I'm passing is 10, 20, and 30. But you see 20 has been changed to 25 because I have changed the element at index position 1. So this is index position 0, this is 1, this is 2. So that's why 20 has been changed to 25. So this is about function arguments. Now let's see what is scope of variables. So scope of variables is well defined in and out of the function. We have two types of variables. One is global variables and the other is local variable. This is global and the other is local. A variable that is defined outside the function and that can be accessed inside and outside the function is known as global variable. A variable which is defined inside the function and can only be accessed inside the function and not outside the function is known as local variable. For example, if I say x equals 1, 2, 3, here x equals 1, 2, 3 is my global variable. So here I'll write a comment saying that this is a global variable. And I'll create a function, let's say def display. And inside this, I'm going to create a local variable y that takes output 4, 5, 6. So let's say this is local variable. And then when I print the value of y, I get the output 4, 5, 6. Inside function, if I print x, I get the value 1, 2, 3. Outside the function, again, I want to print the value of x. And then call the display function. So if you notice here, the first global variable I have written x equals 1, 2, 3. I did not immediately print x after that. Instead, in between I have written in between x equals 1, 2, 3 and print x, I have written the function that is display function. So now what will happen? First, there are 3 print statements here. The first print statement it will print is line number 10 because it is outside the function. Then we are calling the function, right? So from line number 11, it goes to display. Inside display, we have print y, that is, it will print 4, 5, 6, and then it will print x. So now when I go and run, let me run the file. And now you see the output is 1, 2, 3, 4, 5, 6, and 1, 2, 3. Now, if I comment this, and if I write my print statement here, after calling the display function, so what will happen here is, first it will go and execute the print statements inside the display function. So it should print 4, 5, 6 first, 1, 2, 3, and then lastly, line number 12, 1, 2, 3. So it should be 4, 5, 6, 1, 2, 3, and 1, 2, 3. So here the sequence changes. Now, what if I go and say print y? And let's run and check what happens. So you see, it gives me an error saying name y is not defined. Obviously, because y here is the local variable that cannot be accessed outside the function. That is why it gives me an error. Y can only be accessed inside the function because it is a local variable defined inside the function. Now, let's see how we can access global variable with same name. So here what I'll do is the global and local variable name I'll keep same. Now here we will use the global and local variable name same. So what I'll do is I'll say a equals, let's say 1, 1 is my global variable. So I'll say here it is a global variable. And then I'll write the display function, def display. And my local variable name also I'm going to take same. Let's say equals 2, 2. This is local variable. And then print a. So now if I go and run my display, call or execute my display function, Because I have print A inside my display function, it will only execute and give me the output as 22. So you see, I get the output 22. What if I again go and write A here? Okay. And again, if I run, this still gives me 22. So it means that because the local and global variable names are same here, I cannot access my global variable inside the function, but I can do it outside the function. So now when I say print A, this print A on line number 22 will again give me the output as 22 only. What I want is, I want the print A on line number 21 to be 11 and not 22. So for that, we have a special keyword known as globals. And inside the square bracket, we need to mention the name of the global, mention the name of the variable. So now when I run, you see the output is 11 from here, line number 22. 22 from line number 20, that is print A, and then print globals of A will give me output as 11. So here, accessing global variable inside the function using globals keyword. So now this was about scope of variables. Now let's go and see what are lambda functions. Now lambda are small anonymous functions which will not have any name and lambda functions take any number of arguments but single expression. So I'll also write down the syntax of lambda function. The syntax is lambda keyword followed by argument list. So org underscore list colon, then we have expression. So let's say I have, what I'll do is first I'll write a function that is normal function, a function definition to find the cube of a number. So I'll say def cube of n colon return n to the power of 3. And then here I'll say cube print cube of 3. All right. So let me run and check what output it gives. So I'll run lambda functions. You see the output is 27. Now the same thing, the same function definition I want to write in the form of lambda. So how do? I first say lambda. And then followed by argument list. So if you see here argument list, we have only one single argument n colon, then we need to write the expression that is n to the power of 3. And all of this is to be assigned to some variable or lambda function object, let's say L equals. And then I can say print L of 3. And now when I run, you see the output is again 27. So if you see here, lambda functions are very easy to write when compared to normal function definitions. Let's say I have to write lambda to add 3 numbers. Now, how do I do that? Let's say f equals lambda. So when I say add 3 numbers, it means I have to take 3 arguments over here. So I'll say a, comma b, comma c, colon a plus b plus c. And then print f of here. I'll pass 3 values for A, B, C. So I'll say 1, 2, 3. And now when I run, you see the output is 6. Lambda to concatenate strings. Now let's see how we can concatenate strings using lambda. So here I'll say S equals lambda. Let me say comma B colon A plus B. And here I can pass strings like hello, comma, world. And now if I go and run, you see the output is hello world. If you want to have a space, you can either have space here after hello or a space before world. Now you see the output is hello world. Now we will see what are lambda functions methods. Now the first lambda function method we have is filter. Okay. Filters out sequence elements based on some logic and conditions. Now let's see the syntax of filter. So the syntax of filter is filter will take two things. One is function, the other is iterable. By function, I mean here it's a lambda function. And iterable is the sequence variable that we are going to use. All right. Now, what kind of problems we can solve using this filter is, let's say we have to retrieve only even numbers from list of given numbers. So basically this list will have both even and odd numbers, out of which we will be only filtering out the even numbers. So let's say 1, 2, 3, we have 10, 12, 16, 5, 7, something like this. So now how do I retrieve this? First, I'll write down filter and the lambda function inside it. So lambda x colon condition for even number. Let's x mod 2 equals 0 and then LST. That is the iterable. All right. So this entire thing we need to assign it to some variable. Let's say that is result. Result equals filter off, and then I'll say print result. And now when I go and run, you see the output I get is filter object at some specific address. Now it means that the output has been generated, but it is not viewable or printable. The reason is I have to typecast this into list this way. So now when I do this and run, you see the output is all the even numbers 2, 10, 12, and 16. All right. Now, the next method we have is map. So map will or you can say it will maps the sequence elements based on some logic and condition. Again, we'll write the syntax of map. So it is map lambda function, or I can just say function and then iterable. Now let's see where we can use map. So here I'll say in the given list of elements, double each of the list element. let's say list is having elements like 1, 2, 3, 4, and 5. By doubling means I want to multiply each of these elements by 2. So how do I do that? Here I can say map and then lambda function, that is lambda keyword x:x into 2 and then lst. Again, assign all of this to a variable called result. And then I can go and print the result. Let's see what happens. So now when I run, you see the output is, it creates a map object at this specific address. Again, in order to see the output, I just need to convert this into list this way. Typecast this into list, and now you see the output is 2, 4, 6, 8, 10. So it means all of these elements are, or you can say this expression has been applied to all of these elements, x into 2. So it is 2 into 1, or 2 into 2, 3 into 2, 4 into 2, and 5 into 2. This is what map does. Now the last method we have is reduce. So reduce will reduce the sequence elements to single value depending on some logic and conditions. So now, for example, let's say in the given list, sum up all the list elements. So let's say the list is LST equals 5, 10, 15, and 20. Also, let me here write down the syntax of reduce. Again, that would remain same. Here I would say reduce function and iterable. Again, say here result equals reduce. All right. So function is lambda function. Whenever we have to sum up the elements, we need to take two arguments and not one argument. So here I'll take x comma y colon x plus y, because there should be something to which we are adding something, and then pass LST here. So your x becomes 5, y becomes 10. 5 plus 10 becomes 15. X becomes 15, y becomes 15. Then 15 plus 15 becomes 30. That is, x becomes 30, y becomes 20, right? So in total, you get the output as 50. So now when I go and print the result, let's see what happens. Now when I run, you see it gives me an error saying name error, reduce is not defined. So reduce actually is a function that is present in a module called functools. So what you have to do is, first you have to import reduce using this particular keyword or particular import statement. So that should be from func tools import reduce. Okay, so if I uncomment this, you see I get the, you see the error on reduce has been gone. If you ever don't remember this import statement, there is one more way. What you have to do is, you have to just place your cursor over here, and if you click on this, you see you get an option here, or you can just press Alt Enter. You get this option and you can click on it. And if you go back to the beginning of your file, you see from functools import reduce has been imported automatically. So now when I go and run, you see the output is 50. So for reduce, we don't have to typecast or convert it into list, because however, the output is reduced to one single value. So this is about lambda functions. In this session, we'll be learning about how to build a tic-tac-toe game using Python. By the end of this session, you should be able to build a tic-tac-toe game using Python. I'm excited to get started and I hope the same from you. Now let's first understand the board positions and moves for the tic-tac-toe game. So here we will have three boards, that is three rows, board 0, board 1 and board 2. And we will have three columns, column number 0, column number 1 and column number 2. So for the first board 0 and column 0, we have position 0, 0. For board 0 and column 1, we have position 0, 1. For board 0 and column 2, we have position 0, 2. Similarly, for board 1 and column 0, we have 1, 0. Then we have 1, 1 as position, 1, 2 as position. Then we have board 2, 2, 0, where 2 is row, 0 is column number. And here we have 2, 1 and then 2, 2. Now let's see the moves. So in total, we have 9 moves. So we need to here remember that the board positions or board number starts from 0 and moves are from 1 to 9. Now let's see another set of board positions and moves. So here in this board, we'll be having diagonals, and first we will have the column number and then the row number. So if you see here, we have 0, 0. So here we have the board positions that takes the column number first and then row number. If you see here, we have 0, 0. Then so here you see we have 0, 0, 1, 0, 2, 0. Then we have 0, 1. We are here for first considering the column number and then the row number, that is the number board number. So it is 1, 1, 2, 1. Then we have 0, 2, 1, 2 and 2, 2. Moves will remain same, that is from 1 to 9. Now let's hop to the PyCharm and see how we can build a non-graphical tic-tac-toe game only based on Python coding. Let's get started. Now here I'm on my PyCharm, so I'm gonna go to the project name, go to new, create a new Python file and name this to be tic-tac-toe. Hit enter and so here I'll say tic-tac-toe using Python. Now, the first thing what we will do is we will try to print or display the board for our tic-tac-toe. So here I'll write print or display board. And what I'll do is here first I'll take a variable equal board and that will be equal to my empty list. Now what I'll do is I'll take a variable x equals 0. I want to append space. So what I'll do, I'll say while this variable x is not equals a 3, I want to append to board. What I want to append is I want to append the spaces to my list. So here I'll say for I in range 3. So when I take range 3, it means it is 0 to 3. And the range when it is 0 to 3, it will be only 0, 1, and 2. 3 would get excluded. And then I want to increment the value of x. So I'll say x plus equals 1. This is as good as doing x equals to x plus 1. Now we will write a function to display or print the board. So here I'll say print board. Now how do I write a function? It's using def keyword. Here I'll say def print underscore board parenthesis colon. And now what I'll do here is I will run a for loop. I'll say for I in board. Here we have in total 3 board positions, board 0, board 1, and board 2. So the slicing I'll take is 0 to 3. It means it will be only board 0, board 1, board 2. Because this is a slice syntax, it will include 0, but it will exclude 3. It is slicing from 0 to 3, including 0, excluding 3. So we get only 3 values here, 0, 1, and 2. Right? So now what I'll do is I'll make use of a print statement in order to print the board. Now, how will I print the board? I'll make use of the pipe symbol and the placeholders. This way. All right. So here, if you see, we have 3 positions. And then I'll make use of format method of print statement dot format of, to which I will pass I of 0, comma I of 1, and then comma I of 2. And then coming out of the function, I will call the function print board. Now let's go and see how this looks like. So I'm gonna go and run this. So I'm gonna select run tic-tac-toe. This should print a board for us. There we go. This is the simplest board that I have created using pipe symbols and the placeholder. Right. Now what we will do is we will try writing the actual function to move. So here we will have 2 players. One will be your X and the other will be your O, right? So what I'll do is I'll try to get the moves from the player by writing a function known as player underscore move that takes icon as an argument here. So what icon here is, icon is a generalized term for the player names like X or Y, sorry, X or O. And here I'll say if this icon value is equals X, we'll have a variable number equals 1, or else the value of icon equals O, and then I'll have number equals 2. Now inside the same player move function, what I want is I want to write a while loop. So here while true. So this loop will only terminate if we have break statement inside this while loop, because I'm not giving any specific condition. I'm just using the Boolean value true here. Okay. So now I will say print something like your turn player dot format of icon. All right. So I want to specify whose turn it is going to be, either it is X turn or O's turn. Right. So now what I'll do inside this, I'll write a variable called choice and I'll take the input from the user. So here I'll say enter your move, and the move is supposed to be from 1 to 9. As we have already seen, the moves can only be 1 to 9, whereas the board positions can be from 0 to 8, right? Because the board positioning starts from 0. So it will be from 0 to 8. Though we have 9 positions, but when we start counting from 0, board positions would become 0 to 8, right? And now, what I'll do, I'll check if whatever choice the player is entering, okay, if it is in the numbers 1 to 9. So I'll say if choice is in 1, 2, 3, 4, 5, 6, 7, 8, and 9, and the value for choice is not equals space, I'm not supposed to write colon here. Okay. So what we will do, we will typecast this choice into int of choice. So we are converting whatever choice we have here, we are converting into number, because here the numbers I'm actually using is in the form of string, because space is a string and the numbers are in quotations, or the moves from 1 to 9 are in the form of string. So that's why I'm trying to convert that into integer. Okay. Now once it is done, here I'll say if the choice in, we will take the first three moves, okay, list of first three moves. That is, if the choice is in 1, 2, and 3, what should happen? If board of 0, choice minus 1 equals space. Now what does this mean? So here board 0 means the board number 0 or the first board, choice minus 1. If the player is entering choice 1, okay, so 1 minus 1 would become 0, so the board position becomes 0 of 0. If the user or the player is entering choice 2, 2 minus 1 becomes 1, and the board position becomes 0 of 1. If the player is entering the choice 3, 3 minus 1 becomes 2, and the board position becomes 0 of 2. Right? So this is the basic idea. We are trying to get the board position in this way. And then here I'll say board of 0, then choice of minus 1 is equals icon, and then I'll try printing the board, calling the board function, and then I have to break it. And also we will have an else here saying if the board, if this value is not true, right, what should happen? It should print something like the space is already taken. All right. If the choice is not in these three, then it should say the space is already taken. And then I can say continue. And then the next part I can do is I can check for the next three choice. So here I'll say if LF choice in 4, 5, 6. These are the next list of moves, that is 4, 5, 6. And here I'll say if board. Now the board number changes, so this becomes board 1, and choice minus 4 equals space. And then here I can say board of 1, choice of minus 4 is equals icon. I can go and print the board function, and then I can say break, and then else that says the space is already taken. And then continue. Now here, if you see here, the board position is 1. And if the user enters 4, okay, choice 4, 4 minus 4 becomes 0. So the board positions become 1 of 0. So it's on the board number 1, right? 5 minus 4 becomes 1. The board positions become 1 on 1, 1 of 1. And if the choice is 6, 6 minus 4 becomes 2, and the board position becomes 1 of 2, right? Now we'll see if choice is in the last list of moves, that is 7, 8, and 9. So here I'll say 7, 8, 9. And then if board of 2 is choice minus 7 this time, Here I'll say board of 2 choice minus 7 equals icon, and then I can print my board or call my board function. Then I can say brick and an else that corresponds to my if that says the space is already taken. And then here I can say continue. And lastly, here I will have an else that says the space does not exist. All right. And then there will be a continue. We'll see when we completely go and run this, we'll see how this looks like. So right now we have written a code or a function that is going to get the moves from the player. Now the next thing that we are supposed to do is we are supposed to write a function for the victory of the player. So here I'll name the function to be victory that takes icon as an argument. This icon can be either X or O. Now we need to mention the board positions. We need to check the condition here. So here I'll say something like if board of 0, 0 equals icon and board of 0, 1 equals icon and board of 0, 2 equals icon. Then we'll have OR. So this way we will have 8 conditions to check, including the diagonals. So I'll have a OR here. Now the next thing what I'll do is I'll simply use this. I'll copy this, paste it over here. Let me copy this and paste it over here. And this time I'm only going to check the change the positions. So this was 0, 0. Now this becomes this becomes now we'll have the second set of board positions. So that should be 1, 0, 1, 1, and 1, 2. So here I'm going to change this to 1, 1 and this to 1, 2. Similarly, I can go and have the next set of board positions, that is board of we'll first write this structure and then we can fill in the value for board position. So here I'll say is equals icon and board of equals icon. So now let's write the third position. So here it should be 2 of 0, 2 of 1, and then 2 of 2. And then we can just go and write the reverse of the first one. So here we have 0, 0. That will remain same 0, 0. Okay, because here we are only changing the row into column and column into row, right? So here I'll say this is 1 of 0 and then equals icon, and then I can say board of 2 of 0 equals icon. Here I'll say or slash. Here also that should be or and slash. And then board of. So I'm going to now reverse this one. So it should be 0, 1 equals icon and board of. 1 of 1 will become the same. 1 of 1 equals 0 and board of 1 of 2 will become 2 of 1. So now I'll say this is 2 of 1 equals icon. Then I'm going to say or. Now we need to reverse this one. So this is 2, 0 right now. So that will become 0 of 2. So this is 0 of 2 equals icon and board of 2 of 1 becomes 1 of 2 equals icon and board of equals icon. So here 2 of 2 remains same, that is 2 of 2. Now we need to write the diagonals. So let's say board of. The first diagonal I'll take is 0 of 0 equals icon and board of 1 of 1. So 1 of 1 equals icon and then board of that should be 2 of 2 equals icon or slash. I missed the bracket here. And now the last board position for diagonal. So the last one will have is 0 of 2 equals icon and board of 1 of 1. The center one remains same. That's why it is 1 of 1 for both the diagonals. And we have board of equals icon. So lastly, we will have 2 of 0. Yeah. Now we don't have to write this or and slash. Instead, we can just have a colon here because this is an if condition. So let me make this properly indented. And now, let's say written true, else. There might be some syntax error. We'll just go and check that in a while. So this is written false. Now let's see what error it gives. Yeah, there we go. Here is the error. There was an extra bracket and this should be indented properly. So now once it is done, what I'll do is I'll write a function. Not a function, we'll first run a while loop, okay, in order to check if this works. So here I'll say while true, we'll call the function player move with icon X And then here I'll say if victory. To this I'll pass again the parameter x because victory function is taking an icon. Okay, so then here I'll say print x wins, congrats. Then we'll break. And here we will say elif draw. We'll write the draw function later on, not now. Here I'll say player move of O, and then if victory of O, it should print O wins, congrats, and it should break. And then lastly, out of the while loop, it should say something like thanks for playing. Let's go and see if this works. So let me rerun. All right. So now you see it says your turn, player Rex. We'll do one thing. We'll have a colon over here so that it looks nicer. So now when I rerun, okay. So first I'll say the move for X is 2. So you see, this is my second position. Then I want on O on 3, right? And then X on 6. I want O on 5. All right. I want X on 1. And then I basically want X to win this time. So what I'll do is I'll put my O on this position. Okay. So this is 4, 5, 6, 7, 8. Okay. And then X I want on my 4th position. And then O I want on my 9th position. And then when I put X here, basically X wins. So I'll say 7. And now you see it gives me an output saying X wins, congrats. Right. Similarly, I can also make O win. So this time we'll try making O win. So here I'll say 2, 3, and 1. Let's say O is on center. All right. I want X on my 4th. I want O on my 6th. Now I want X on my position 8. And then you see, if I put 9 here, so see, O is already 1. O wins, congrats. Now what I want is I want to make a draw. So here I'll say 2, 4, 1, and 3. All right. So I can say, if I say 5 here, okay, and I can put O at 8th position. And because I want to draw, I don't want to put X on 9. So I'll say, let's say, okay. And then now you see, I'll have O on my 6th. Oh, sorry, by this actually X is winning. Let me try putting the moves by which we can get a draw. So let's say 1, 2, 3. Let's say this is 7, 4. Now X will be 6, right? O will be 9 and x is 8. So you see what's actually happening? All the places have been filled, but still it is asking me for the moves, right? So the reason here is I actually want to, at this moment, I want to say that it is a draw. So for that also I need to write a function. Let's go and see how to write that draw function. So after this victory function, before this while loop, I want to have a small function that says def draw, that will not take any argument. Okay. And here I'll say if space is not in board of 0 and space not in board of 1 and also space not in board of 2, okay, this is the condition that I have given. Now it should say true, else it should return false. Else it should return false. All right. So now I need to call this draw function. So I need to do that in my while loop here. Once victory is done, after breaking, I need to have an elif that says draw. And here we are simply going to print that says it's a draw. And again, we have to break, or it's, we have already breaked here. So let's not write the break again, but here I'll say elif draw. Here I'll say it's a draw. Now let's go and see. Let's rerun. And this time we'll make it to draw. I'll say 1, 2, 3. O will be, let's say 4. And X will be, let's say 7. Now O will be on my 5th. Okay. X will be on 8th. And O will be on 9th. And X would be on 6th. So you see now it says it's a draw. Again, it's continuously running your turn player 0 because the reason is, let's not have this continue after each and every condition. Okay. So now what we will do is we will check for different conditions. All right. So what will happen if I put a move 0 here? So you see it directly says me your turn player X. What will happen if I give some number like 100? So it will again say your turn player X. What happens if I simply enter? So it's a invalid literal. Or if I try giving negative value, if I say something like -4 and you see it says your turn player X. So I want to, whenever I do this, I want this to be displayed as invalid input, right? So for that, what I will do is I'll go here in my player move function where I have collected the moves from the player. So here what I will do is down here, okay, where I'm checking for the choice, it should be properly aligned. So if you see, here is my if choice. I want to go down this way. And then here I can write an else that says print invalid input. And then I can say continue. Okay. So now when I go and rerun, Now you see, if I say 10, because this 10 is not from 1 to 9. So you see, it says invalid input, and again, it starts your turn player X. If I say -1, you see, again, it gives me the same. If I say 100, it still gives me the same, saying it is an invalid input. So anything that is not in between 1 and 9, including 1 and 9, will give you the invalid input, right? So now I'll again rerun. Okay, here if I say I want X to be on my position 2, again if I say 2, what will happen? So you see, it says the space is already taken. So now if I try entering O somewhere else, now you see O is entered somewhere else. Okay, so now let me put 1 and 3 and 5. O is, let's say, 8. And then I want my X on 7 and my O on 8 and again X on 9. So now you see it says X wins. Congrats and thanks for playing. So here if you see there is some problem in the moves, let me go and check the positions I have given. So here it is 0, 0, 0, 1, 0, 2. This is 0, 0, 0, 1, 0, 2. And then I have 1, 0, 1, 1, 1, 2. All right, so I missed one of the positions. So what I'll do here is I'll say 2, 1, 3, 5, and let's say X is on 4. And let's say O is on 6. And X is on, let's say, 7, 8, and 9. Now you see it's a draw. And then it gives me your turn player. Oh. So why is it saying this your turn player row after it's a draw? Because I haven't say a break after my draw. So now when I go and say break and rerun, okay, so I'll say 1, 2, 3, 5, let's say 7, 4, 6. All right, and O I want on 9 and X I want on 8. So now you see it say it's a draw. Thanks for playing. Because I haven't written break, it was again continuing because of the while loop. So this was about how we can have a tic-tac-toe game built using Python. It's a purely non-graphical, it's not graphic based, but it's only purely coding based game. So I hope you enjoyed the session. Thank you so much.